WeAreDevelopers is my favorite conference. It's the only one I'm going to this year because it's really for developers, it's by developers, all the content is real technical programming content.
Hello everyone and welcome to a new episode of the WeAreDevelopers Live Days. My name is Benedict, I'm Community Manager here at WeAreDevelopers and I'm glad that you all made it today. So, new year and a new season, the fifth one to be precise. But not only our Live Days get a new edition, also our World Congress will be back as an in-person event in July in Berlin. Let's have a quick look into it.
To reach so many people face to face in one place is quite unique.
So, if you're interested, go to worldcongress.dev for further information and to claim your tickets. And now we will go back right to the Java Developer Day. And during the talks, as always, feel free to interact with the chat to your right. If you got some questions, submit them in the question section, as we will have a short Q&A after each talk. But during your interactions, please be nice to each other and respect each other, as we have a code of conduct. Here's a short video about it. And right back to Java. The first speaker of the day is lead developer at the Austrian Federal Computing Center. He studied at the TU Wien and works in the development sector for about 15 years now. Welcome, Gregor.
Good morning, and thank you, Benedict, for the invitation.
Yes, thank you for joining us today, Gregor.
Yeah, thank you. It's a great opportunity for me to also try this and talk at this WeAreDevelopers Java Days for once. And yeah, I'm excited about this opportunity.
I'm certain you will do fine. Maybe for a quick start, would you mind introducing the audience and me a bit to the topic we are going to learn from you today?
Yes, gladly. I want to talk about Hibernate and yeah, how to keep calm, let's say, because we are using Hibernate in all of our projects, And I just want to talk a lot about Hibernate and JPA and its integration with Spring in general, and then about some findings we had and use cases we had to do, and the problems we had there, and yeah, how we addressed them, and the solutions we found for these problems.
Perfect. Gregor, sounds awesome. You got my full attention. And I would say, without further ado, stage is all yours.
Okay, then thanks again for coming. My name is Gregor Lucny, and I'm talking about Hibernate and how to keep calm. As I said, we are using it in all of our services in a lot of varieties, from front-end applications with front-end and back-end code, but also in batch processes and with long-running tasks. And yeah, in this talk, I just want to talk a little bit of why we use it and about our experience with that. And this session will also contain lots of code samples, so I hope you will enjoy that. A little bit about myself. My name is Gregor. I work at the Austrian Federal Computing Center, and I'm currently working for the Austrian Public Employment Service, for the AMS. There we have 4 development teams, and yeah, as I said, I'm the lead developer of one of these teams. And our tech stack in our services, we are trying to do a microservice architecture, is for all services quite the same. We are using Java, we are using Spring Boot and JPA and Hibernate in all our services. All services with front-end have an Angular 13 or 14 for the front-end technologies. And we also use third-party services like Elasticsearch. Little fun fact about myself: in my off time, I'm doing, as balancing to my normal work, historical fencing. So yeah, fighting with medieval weapons of all sorts. If you're interested about that, you can ask after the session. And a word to my colleague: I initially wanted to make this talk with my colleague Philipp Frauenthaler, but he unfortunately got ill last week. So yeah, now you're stuck with me. As I said, this talk will have lots of samples. And just to establish the context of this a little bit, I'm leaning on my current work experience with the AMS, with the Public Employment Service. And let's say, for our examples, we have a platform to search for jobs. A user can register on this platform and save search queries about jobs, and also register devices on which he is informed about jobs. So in all these examples, we will have this quite simple data model of a user, and the user can have a list of saved search queries in the backend, and he can also have a list of devices that he wants to be notified about. I've also put all these examples on GitHub. You see it in the source code link, and yeah, feel free to check that out. I guess the question every one of us had in his development career is how to access the database, or in this case, a relational database. I guess the goal is to read and write data from there, and because we are using Java and working with Java, we want to handle it in an object-oriented way. So we normally have a Java class representing our tables. And based on our data model I said before, you see here we have a class user that has some properties with an ID, username, an email address, and also a date that's like when he registered. And the easiest, or let's say traditional approach to access the database would be to use JDBC, the Java Database Connectivity API. We're not going to look at that a lot, but you just see it's lots of code. It's quite messy. You have to deal with the connection handling. You have to write your SQL statements. You have to set the parameters right. In the left example, in row 12, you see I have to deal with type conversion because I'm using a local date and have to convert it to a Java SQL date. I have to do transaction handling. SQL exceptions can occur. So yeah, there's a lot of work to be done to access my data in my database. And yeah, So the question is, how can these two worlds, a relational database and my object-oriented world in Java, fit together? Of course, there is, because we have our objects on the left-hand side in our applications, and if I write something, it corresponds to these insert statements or update statements. And the other way around, if I want to read something, I have my select statements that you have to use in the database. And yeah, want to wrap it back to some Java objects. And yeah, the GBC way is one way, but of course there's a possible answer how to do it easier, because that's why we're talking today. And that's the use of JPA or Hibernate. A little bit of clarification, JPA stands for Java Persistence API, which is the specification, what this object relational mapper should do. Hibernate is one of the implementations. There are other ones like Eclipse Link, but in my time in the software engineering world, I've only used Hibernate so far. So this means for the rest of the talk, when I say JPA or Hibernate, I will use these words as synonyms, because yeah, when I'm talking about JPA, it's always Hibernate under the hood. What are our motivations for using JPA or Hibernate? Of course, the obvious one is to have an easy mapping between my Java classes and tables, to map my properties to columns and so on. But JPA also supports you in mapping relations. So if you have relations between tables, you can also represent it in the Java objects. There you have the possibility to say, if you want to have related object loaded lazily, which is the default, or eager, so immediately when you fetch an object. Hibernate also supports you with stuff like key generations, if you want to use sequences or identity columns or UUIDs. There's also built-in features for optimistic locking, so you don't have to use pessimistic write locks and yeah, put more load on your database. Hibernate does some performance optimizations, like if I have a transaction and update one entity or one object multiple times, these changes get aggregated into a single update statement at the end of my transaction. Hibernate also supports you with stuff like DDL generation, so I can generate my schema from these classes, and so on and so on. Hibernate helps you to also be mostly or program mostly database independent. I say mostly because there are always these special cases where you need to map your class to a special column type of a database, or where you have to use features like stored procedures, or there are some databases that don't support deferred constraints. So be aware of that. But I would say 90 to 95% of the time, at least, you can work with Hibernate independently of your underlying database. Hibernate also helps you with type and parameter handling. Like in the example before, I had to convert my local date to a Java SQL date. And yeah, this works for all the new temporal types like local date time, local date with time zones, Java util date, and so on. And there's another nice feature Hibernate supports, which is caching, but I will talk about this later a little bit more in detail. Let's look at a simple Hibernate mapping. There we have a user class again. You see in the row 2 to 3, I'm defining, okay, this is an JPA entity, and it maps to the table user sample 1. In the row 6 and 7, I mark the ID as ID field, and also defined a generation strategy for this ID. So I want to use an identity column in my database to generate this ID. And in the rows 10, 13, and 16, I defined which properties map to which database columns. And also put in an additional stuff like, are these nullable fields, or is this an unique column, which can be useful if you're using this DDL generation feature. And here on the left-hand side, you'll see in the bottom left box how we insert a user when you're using Hibernate. You see we just get the entity manager, start the transaction, persist the user, and commit the transaction again. And everything else, the mapping to tables, the mapping of data types, and so on, happens automatically by Hibernate. And yeah, in the left bottom, you see the equivalent for fetching a user, which is just find the class name plus the user's ID. Hibernate knows, according to this, because of the ID mapping, which column to use to fetch the user by its ID, and just returns it. So really much less code than before with using GDBC. A good thing to know or to keep in mind when using Hibernate or JPA is that all these entities have a specific life cycle, and each new entity starts in the transient state, so it's not attached to the database or anything. It's not stored. And as soon as you persist it, like in the top left example in row 5, it gets in the managed state, so it's attached to a transaction or Hibernate session, and all changes I do to this object while it's in this managed state are reflected back to the database. As soon as my transaction ends, my session closes, and this entity goes from the managed state to the detached state, which means I still have it available. I can use it in my Java application, in my service code, but changes don't get reflected back to the database. And if I want to change it in this detached state and persist it again, I have to merge it into my current entity manager context and then it's in the managed state again, and all changes are persisted to the database. Keep this in mind. This is important for one of my later examples, that there is this managed and detached state an entity can have. A quick word about caching. As I said, all entities in managed state are saved by Hibernate in the so-called level 1 cache. This cache exists as long as the transaction is open, as long as it's alive, which means the first time I fetch an entity by its ID, Hibernate is going to the database, fetches it, and then puts it in its level 1 cache. If I fetch it again, like in the example in row 5 and 7, the entity is fetched from this level 1 cache, from my session, and not from the database. So Hibernate reduces the round trips to your database. You, as a programmer, can use it in different services, in different layers of your application, as long as you're in the same transaction. But it's also used by Hibernate internally if one of your entities needs to fetch another entity with a mapped relation. So yeah, and this session exists as long as, this cache exists as long as the session is available, so as long as the transaction is open. If you need a longer cache, there's the so-called level 2 cache, which is shared by all sessions and lives longer than transactions, and normally used for entities that are read quite often, but written only sparsely. But that's not, I just wanted to put it out there that there is an option for that, but it's not the topic of this talk. Now I've talked a lot about JPA and Hibernate. A quick word to Spring. I guess most Java developers know Spring, and a lot of you are using it. And Spring has a great integration to work with JPA and Hibernate. And if you're using Spring Boot, for example, it makes it even easier with automatic configuration to access your database or your JPA configuration. You get out-of-the-box features like connection pooling. You get Spring's transaction management, which you can do imperatively in the Java code or declarative only with annotations. And on top of that, there's also the Spring Data JPA library from Spring, which we're also using in all of our services. That helps you. That is an additional abstraction layer on top of JPA or Hibernate, and helps you with all your operations you want to do with the database. It simplifies the JPA repositories because you most of the time only have to define interfaces. It generates automatic JPA queries through codename conventions. It has pagination support. You can stream data from your database, and so on. So there are really a lot of features. If you don't know that, please look into it. And there's also an example how you can use that. if you're looking at the bottom box, I've defined a repository for my user class, but as you can see in row 2, it's only an interface, it's not an implementation. In row 4, I define a method find by email, and Spring Data automatically generates the select from user, where email equals my parameter. This is done automatically. And if you need to be a little bit more fine-grained with your select statement, you can also use the query annotation, like in row 6, to write your query. But as before, you can leave the implementation to Spring. In the bottom box, in this example, I use this repository. There are two interesting features. In row 1, I defined that this method users should you open a transaction, which means Spring makes a transaction proxy around this method, starts your transaction before entering it, then the method executes, and after returning from it, the transaction is committed, or in case of an exception, rolled back. The second interesting fact is when you look at the bottom box at row 5, or the 3 to 5, I fetched my user. My user entity is now in this managed state, and then I change the username, but I never save it. This is not needed because it's a managed entity, so all my changes are reflected back to the database at the transaction commit. This was about a lot of overall stuff about JDBC, Spring, and JPA and Hibernate. So let's talk about some of our findings. Just as a reminder, for this example, I'm using this data model of a user that has a list of search queries and a list of devices. One of the first problems we had, or challenges we had, was to keep the classes and your database in sync. Because, of course, your classes have to correspond to table names, your properties have to correspond to column names, and so on. And what we were in the nice position that we could make the database schema from scratch. So we used the features from Hibernate to generate at least a draft version of the database schema from our entities. And I would recommend to everyone to use a tool like Liquibase or Flyway to execute your database migrations. To the people who don't know that, with these tools, you can define a set of statements that should be executed on your database, like create table statements, modify data types, create indices, and so on. And like we used it, this is executed on the startup of each service. It checks the available change sets against the current state of the database. And if they're still missing change sets that were not executed before, it does that automatically on startup. So you don't have to manually migrate your database to the current data model in a maintenance window or something like that. To help you with the generation of these change sets, you can use we in our project use Liquibase. You can use the Liquibase diff plugin to generate a diff between your current entity classes and the database. And if you look at the code sample, the interesting part is in row 6. I define that as one point of reference, all my entities in the package that I put there, and I compare it to for example, if you're developing on your code with my local database. So this plugin looks at what should my database look like, what are my currently available old change sets, and prints out the difference between what is new, what you would need, and the current state of a database. I wouldn't use these generated change sets exactly as they come, but I would say it brings you about 2/3 of the way for easily generating your changes you need to keep your classes with your database in sync. Another challenge we had was how we used IDs, or what IDs we used. We started with using, like in my first example, with using by Hibernate generated IDs. with entity columns, so our IDs should come from the database. But we came across some drawbacks when using that. The first thing is, if you're using a generated ID, it's only available when you persist your Hibernate entity. So it's not immediately available in your business logic, which could affect, for example, your equals and your hashcode methods. Or you can't lock this entity before persisting it. Or you can't send it to another service or something like that. We also came across the fact that since we're using an entity, this was an identity column, we had auto-incrementing IDs that are guessable, and we didn't want that because they were available in our front end. So this was also not the greatest choice. And it was also harder to copy between stages. We had the issue that we wanted to migrate from our virtual machines to OpenShift. And when you just want to copy all your data from this one stage to another stage, you have to work with, you have to reset or change, for example, your sequences or the current number of your identity column and so on. And if you're using these auto-generated IDs, you also have the problem that you have different IDs from different stages. Think about fixed values that, I don't know, only change once a year. And they're different on each stage. So it's probably harder to analyze production errors because different IDs mean a different thing on each stage. And you can't just give a predefined ID in your entities because if it's auto-generated by Hibernate, it just gets overridden during the persist action. So our solution for this problem was to use UIDs to get rid of this auto-incrementing problem. We could also, with that, copy data between stages if needed. And we didn't generate the UID we generated it by ourselves and didn't let it generate by Hibernate, because then we could also override it, like giving an own UID in a constructor. And this is the next challenge was how to use the equals and your hashcode method. I mentioned it before in your at the ID. How do you normally implement your equals and hashcode methods? I would say the normal approach would be that these methods should include all properties. This happens by default if you're letting it generate by your IDE or, for example, by Lombok. But when using Hibernate, you have to be a little bit aware of some stuff. For example, as I said, the ID is not always available, which means the equals or hashcode methods have a different result depending if your object is persisted or not. If in your class you have mapped relations, especially with one-to-many relations, these relations are normally lazy, which means these objects aren't there. So if you access them to generate an hashcode, Hibernate would try to fetch these from the database, which means additional load to your database, what you probably don't want. Or if you're no longer in the managed state, but in the attached state, you would get runtime exceptions. You could also have the problem of cycles. Let's think about our user references all our devices, but each device references back to our user, so you could get a cycle, which led to the question, how is an entity identified? Is it identified by all of its properties or just by its ID, or possibly by a subset of its properties like its ID or version? And we came to the conclusion that if we needed to implement equality checks, we implemented them where we needed them, like in the business logic, because most of the time we only had to use a part of the properties for a current use case or a requirement. And if you need to implement your equals and your hashcode method in your entities, for example, when you're using them in a set or in a map, we only use the IDs because this ID is stable and immutable. And normally, when you're thinking about the database layer, if we want to know if a device is in my relation table from a user, I normally in database way, I need to know if the record with the ID is associated with this user, not if all of its properties are equal. So these were some examples of a little bit more general nature. Let's get into some use cases. These are real use cases we had in our services. I adapted them and simplified them for this talk, but I think you will get the general idea about it. Let's say we have the use case that I want to send notifications to all users when they have no new search results. So the simple solution would be to fetch all the users, iterate over all the search queries, check if the search query produces a new result, and then, if yes, iterate over all user devices and notify them. Sounds good, but when you put it in production, you see my service is slow, this notification process takes a long time. What now? Hibernate has great features to analyze what's going on under the hood, because sometimes it's not what you expect or what you wanted. So you should analyze the queries. You can enable the org Hibernate SQL logger to see what SQL statements are really done by Hibernate. And there's also this cool feature that you can enable generate to create statistics about your sessions, or even how many results did a query produce and how long did it take. And if you see in the code snippet, as in the log snippet, in the box, in the first row, we see we had our select from user statement, which produced 2 rows and took 6 milliseconds. But in the statistics of the session of this transaction, I executed 5 statements. Well, why is that? Because I only had my find all method, 1 statement. Yeah, if you look at it, I'm executing this find user statement in row 3, but all my relations are by default fetched lazy. So I have an additional SQL query for my search queries in row 5, and another one for the devices in row 9. I had 2 results, which means 4 queries. In addition, comes 5. Our solution for this problem was to fetch related entities within the same query. As you can see in row 2, you can just say select from user and make a join fetch to the search queries relation and a join fetch to the devices relation. What happens under the hood is that there is really a join statement done in SQL. You get your cross-join result, and Hibernate maps them automatically to your user and to the related entities. If you are doing these fetch joins, you always have to keep in mind, or you always have to use the distinct keyword in your queries, because otherwise you would get your user 2 times. If I have a user with 2 devices, it produces 2 results in my query, and Hibernate would normally map that to 2 user objects. So you need to use distinct to deduplicate that. If these relations are optional, so if I want the results even if there is, let's say, no search query or no device available, you have to use left join fetches. Otherwise, it would get eliminated from this join. And if you don't want to fetch all relations at once, let's say you have an object with 10 related entities, or 10 relations, you can also fetch relations at a time, like in row 5 and 6 or 8 and 9, where I just fetch only the queries or only the devices. And if we're using that in our code, in the bottom box is the usage of the find all fetch relations. And then the user is initialized with all its relations. And if I want the more fine-grained approach, it's the bottom box. I just fetch all my users, and then fetch all search queries for all my users, but in one query, and I do that again for my devices. Sounds good. We made it a little bit better with less queries, but we still ran into problems because we're still loading all our users at once. So the first initial query takes quite a long time and produces lots of results, which needs a lot of memory. And we also had the problem of transaction timeouts. Think about a big amount of data that do processing per item that's not related to your transaction, and for example, updates your Elasticsearch index. So we really had the problem that the connection to the database got idle, and yeah, we had timeouts with that. How did we fix these two problems? We use streaming. So we started to stream our users from the database, like in this example in row 10, to only fetch an amount of users at a time and generate the consecutive calls to the database, which means the first statement doesn't take that long. You don't need that much memory. And yeah, in general, it should be faster. The thing is, when using streaming is you have to think about your database or your JDBC implementation you have, because you have to set the fetch size, like in row 7, to a good value. For example, in Postgres, the default fetch size would be 0, which means still all rows get loaded at once. The default fetch size for Oracle would be 10, which is also, depending on the size of your object, probably not optimal. So there's something you can improve with your queries. And if you're using query hints, we can use some other ones, like the read-only query hint, which tells Hibernate, I don't want to edit these objects, so you can omit your dirty checks at the end of the transaction to speed up your code. And you can also say, I told you before, you have to put in the distinct keyword to get each user only once. But this is done by Hibernate. This is not done by the database. The database would produce multiple rows per user because of its relations. So trying to distinct these rows in the database doesn't make no sense. You can save database performance when telling Hibernate not to pass it through to your database. The usage of this method would look like this. In row 3, we have our stream all fetch relations. In row 5 and row 9, we don't have to do additional queries because they were all fetched at one time. But there's another thing I put in there in row 14, and I detached my user after processing it. This is, if you remember, all loaded objects or all loaded entities are in this managed state and in the DLL1 cache, and stay in this session as long as the session or transaction is open, which means they are getting more and more entities in there over the time of your processing. So your application needs more heap space, probably is getting slower, starts paging, and so on. And to prevent that, you can detach your entities from the entity manager to allow the JVM to garbage collect them if needed. Another use case we had was we wanted to inform other services about changes. Other services that are connected via REST or something like that. So let's say we want to inform our notification service about a new device from a user. So our user registers a new device. What would you normally do? You start your transaction. You update the user in the database with the new device. You make your REST call to the notification service to tell this service, okay, there's no new device available. And then you end your transaction. Sounds good, but what happens if this end part does not work because there's a unique key constraint violation, or the database connection get an error or something like that? So the overall problem was there are systems that don't participate in the same transaction as your Hibernate transaction. And rollback actions that are happening on a database don't happen automatically for the systems. Our solution for that was to use custom rollback actions and make use of Spring's transaction synchronization manager, which can automatically run these tasks, these rollback tasks, on a transaction rollback. And an implementation would look like this. In the top box, if you want, you see the implementation, how to connect or how to utilize this transaction synchronization manager. You have to implement this transaction synchronization interface. And in row 7, you see if this transaction has the status rollback, we just iterate over our registered rollback actions and execute them. And at the bottom box, you see how to use that. I create a new rollback transaction synchronization. I add rollback actions. I can add multiple of them in different services or different methods, as long as they are all in the same transaction. And then I use this transaction synchronization manager to register that. We wrap that in a service, in a utility service. And when using that, it would look like this. In my method add device, I have in row 6, after I'm changing my database record, in row 6, I make my call to my REST API. And then in row 7, I just use the rollback manager to add a new rollback actions. And I could do this multiple times in this method or in other ones, and they would be aggregated and automatically executed by Spring on a rollback. The nice thing is, this also supports embedded transaction and this declarative transactional approach from Spring, because it doesn't matter if my transaction is started in my service or in a calling service higher up the call chain. It's still using Spring's approach on transaction management. There's a third use case I want to talk about, which is we had the requirement to propagate changes from our data to other services via a message broker. So let's say we want to propagate every time a user changes, a user object changes, this to other service by putting a message on a message broker. And yeah, the ordinary way would be to just make a custom implementation at each point the user changes to send these messages to the message broker. The solution we took there was to make use of Hibernate's entity listener hooks. For example, there's the possibility to get notified before or after a persist. This is a post persist, a post update. And we use these hooks to convert entities into message DTOs and send them to a message broker. So every time a message gets persisted or updated, this entity listener gets fired, converts this to a data transfer object, which is the message, and then puts it on a message broker. For this, we implemented a global entity listener that only required to configure which entity corresponds to which data transfer object and on which queue or topic this listener should put the message, and everything else worked out of the box. If you're interested in that, you can also ask later. I'm happy to talk about that. There are more topics that we had to deal with while using Hibernate and JPA, like are we using field or property access? How do we deal with entity inheritance? Are we using lists or sets? But that's unfortunately a little bit too much and too long for this talk. Just to wrap it up a little bit, I think Hibernate and JPA, especially in combination with Spring, is a great tool to simplify your code and to improve development efficiency. But you have to be aware that you don't have full control of your database layer. And you should regularly, especially if you're having performance issues or have the feeling that your application is slow, review and analyze your code and make use of Hibernate's logging features to print out what statements are going to get executed, how long they take, how much result they have, and so on. Because of this, from time to time, there's quite detailed knowledge required about the internal workings of Hibernate, how these lazy proxies work, and so on. And even if I'm a fan of JPA and Hibernate, always keep in mind it's not always the right tool for the job. Probably if you have some performance requirements, just use plain JDBC, or another database like an OSQL database are better for the job. With that, I want to close my presentation and are very excited to answer any questions. And if you have longer questions or think about them later, you can always send them to me or to my colleague Philipp, which unfortunately wasn't here today. And we'll try to answer them as best as we can. Thank you for your attention, and I hope you enjoyed the talk.
Hello again, Gregor. Thank you so much for the interesting presentation. I always love the use of memes, so you always know you're on the same level of humor. So before we start with the Q&A, one colleague of you wanted to join, Michael, who is also senior full stack software engineer at the Austrian Federal Computing Center. Is that right?
Yes, that's right.
There he is. Hello, Michael. Nice to have you as well.
I'm here to support Gregor a little bit in the Q&A session due to the illness of Philipp, and I am ready to go.
Yeah, and I said after 40 minutes of talking, I probably need a little bit of a pause.
Yes.
Yeah, I can relate. All right, you two. You two have much experience already as developers. Maybe you could enlighten me and the audience on how you started to become a developer. What was like your journey?
So probably I will take this question.
Yeah, I get.
Yes, so I can talk to both of us because we had a very similar career, so to say, because we both do a technical high school, and after that we are joining the Austrian Federal Computing Center, and we both studied part-time there at the Technical University of Vienna, of the TU Wien. And yes, so for me, I started as a developer who does supporting and third level support and stuff like that. And then I also had a little bit to do with project management, and I then come back to software engineering, and now I'm a lead developer, the same as Gregor. And yeah, I really liked it. I really liked my current job position.
Yeah,
and so it was. Sorry.
No, I just wanted to say, and it's quite the same for me. I started after high school. I'm in the Austrian Federal Computing Center since 2007, I think. Yeah, studied part-time parallel to it, and yeah, I would say worked my way up from junior developer to more experience with requirements engineering, also a little bit of project management, and now going into a little bit of this lead developer and architecture role, I would say.
And so it was always Java for both of you, or was there like a transition from other technologies?
No, I mean, of course, at school I learned other stuff like C++ and also a little bit of COBOL, but most of my education was done in Java, and yeah, I'm using it ever since, and I don't think I will ever switch to something else. I'm interested in other stuff like Python and so on, but yeah, the most experience I definitely have in Java.
Yeah, for me, it's basically the same. I'm also more or less a Java expert, and I do this many years. But yeah, we are full stack developers, so we are doing a lot of TypeScript with Angular, and I also have done some .NET. and don't forget Groovy in our Jenkins pipelines, and a little bit of Kotlin.
This is a special case, I would say.
Yes. Yeah.
Okay, but to sum it up, one could say you are very dedicated to Java. What you are also dedicated to is your workplace, the Austrian Federal Computing Center, and you're both working on same projects or different. Maybe you could tell us a bit about your daily work there.
Yes. So I can start this question or this answer. We are working in now 4 Scrum teams, which are more like 4 or 5 persons. It depends. And we are doing different products, but for the same account or for the same customer. So yeah, we are working together in some cases, but we are in different Scrum teams, and we are trying to trying to communicate between these Scrum teams, because we are now a lot of people, and communication and collaboration is really difficult or really challenging. And yeah, we are using the tools of the Agile project management and the tools for, which Scrum has for us. And yes.
Yeah. I think we're also trying to, synchronize our way we want to do code quality and stuff. So we want to try to have the same level of testing, level of code quality, use the same techniques, the same code conventions, and we are working together to ensure that for all the 4 Scrum teams we have.
Yeah, I also know that it can be a bit difficult with interaction between the teams, but I think it's very nice when then at the end everything comes together in the final product and everyone is happy with it. So, and when or how does someone start at your company? Like if someone is a young developer, like just graduated from high school or something like that, are there like openings for that?
Well, I think you can start as a junior developer or as a senior. I think we're looking for both people in both positions. As in my case, I started immediately after school. And we also have a trainee program for people that don't have an IT, or at least not an extensive IT or software engineering education, where you can learn software engineering and learn to program in Java and Angular and so on at the Austrian Federal Computing Center. And yeah, I think we have lots of open positions, but yeah, not only for the development jobs, but also for requirements engineering, analysts, project managers, and so on. I think we are always looking for good people.
Yes, I think I have nothing to add here.
All right, yeah. Talking about career, we got a question. I'm currently a junior project manager who worked with agile methodologies, and I'm aiming a career change to a Java developer. I've started my studies at the university. Is this transition possible? What would be the challenges? Note, I didn't have prior tech knowledge, but currently learning Java, SQL, Spring, etc.
Yes, it's definitively possible, in my opinion. So, as for every career change or for every thing you want to learn, you need to have fun with it, to try things out. I think it's the perfect way to start is to have an own project, which you like to do or which you like to implement, and with this you can take the small steps. So first you start with a very small program, and then you add features. More or less, we do the same also here in our job. And yes, and with this adding new features, you will get new experiences, you will learn new things, and I think learning Spring, Java, and SQL are two very good starting technologies for learning programming.
I guess if you have a little bit of your own project you're starting with to learn, it's also a great start to see if this really is the thing you want to do in your future career. And if you're really interested in that, and if you say, hey, that's my new stuff, I want to do more of that, I think that would be a great start, for example, to apply for one of these apprenticeships that Bert said.
All right, thank you for that answer. We got another question. Remote or only local attendees? If I'm interpreting this correctly, he is referring to the job applications at your workplace.
Okay. So yeah, currently during the COVID pandemic, we were facing a lot of home office. So there were also 100% home office days
for a long
months.
For a long time, yeah.
Yes. But now, I think since a year now or something like that, we are having so 60-40. So it means 60% working remote and 40% working in our office in Vienna. And personally, for me, it's a good balance between working remote and staying in touch with my colleagues, socialize a little bit, and having fun in the office too.
Yeah, especially Wednesday is our meeting day where we do our refinements, our planning, and this is, for example, a day but this is only specific to our team. But this is a day where we want the people to be in office to communicate with each other, collaborate, and talk about the next sprint. But on the other days, you are quite flexible when to stay at home and do home office, or when you're coming to work. You can also arrange that as you like during the month, so it doesn't have to be 2 days a week or something like that. So I think we got quite flexible now, and it's I think a good mix to stay in contact with colleagues and organize your life at home, let's say.
And save time with commuting.
Yeah.
That's so true. Thank you for that answer as well, you two. We got a bit more technical question. Hello, Gregor. Thanks for the presentation. In slide 21, how is Hibernate able to fetch the data of devices and search queries without having the multiple backfetch exception?
Slide 20.
21.
Can you repeat the question? I'm sorry.
How is Hibernate able to fetch the data of devices and search queries without having the multiple backfetch exception?
I think you're referring to the that's one. I think you're referring to the problem with lists and sets. If I understand it correctly, that's one of the questions we had. Should we use lists? Should we use sets, for example? If you're using if you're fetching multiple relations in one fetch join, they have. I think you only can have one list. All the other ones have to be sets. Otherwise, you get this multiple backfetch exception. If you want to circumvent that because you want to have lists because you need ordering or something like that, you can fetch the relations in separate calls, like in row 5 and in row 8. You would still have one SQL statement per relation, but it's only one for all of your entities you're fetching with your ID. But this is one of the things you have to keep in mind if you're using lists or sets, or bags or sets in that case.
All right, thank you, Gregor, and thank you also, Michael, for the awesome Q&A, and Gregor for the awesome presentation. Thanks for joining us today, and hope to see you in the future. Bye.
Thank you very much. Thank you, Benedict. Bye-bye.
And before we now go on to the next speaker of the day, quick information for the audience. We are giving away a MetaQuest 2 together with our partner Deloitte. Just scroll down on the live page and to join the raffle. And now, right back to Java. With the next speaker, he is Director of Developer Experience at Red Hat and has a passion for software automation and the Java world as a whole. Welcome, Alex.
Hello, good morning there. I'm super excited to be here again. I mean, I was physically in Berlin last year. So yeah, this coming here again, even though it's online, it's always a pleasure.
It's not the same, but sharing knowledge is always fun, I think. So
yeah.
Happy that you're happy. Maybe before you start, would you mind telling us a bit about what we are going to learn from you today?
Yeah, today we're going to try to see a possible solution for avoiding dual writes. You know that dual writes are problematic when you are doing microservices architecture. So here we're going to explore how we can use Kafka and Kafka Connect to avoid these dual writes. Of course, it's just a way of doing it. There are others, but today we're going to focus on this.
Okay, let's learn it your way today, Alex. I'm hyped for your talk, and I would say without further ado, the stage is all yours.
Thank you very much. So I think that I'm already sharing my screen. I don't know if you can see my screen now.
Not yet.
Not yet. Well, I'm going to stop sharing and sharing again. Let's see. Yeah. Now? Now. Okay, perfect.
Perfect.
Yeah. Okay, so let's start with the session. As I said, the session is named Practical Change Data Streaming Use Cases with Divisium and Quarkus, because basically what we're going to see in this session is how change data capture can help us on avoiding dual writes using Kafka Divisium and of course Quarkus, because I'm coming from Red Hat and and Java, so the Quarkus is the framework that we are supporting nowadays for microservices. But the good news is that if you are not using Quarkus, you're using Spring Boot. We also offer in the GitHub project, you'll see also an example using Spring Boot. Or even, for example, if you say, but I'm using Python or Kotlin, or it works in the same way. So no worries. There is no, this is just an example, but you'll see that Kafka, Divisium, and Kubernetes can be used with any language. My name is Alex Soto. My Twitter is Alex Soto V. You can follow me there. And if you've got any question, of course, you can do it in the platform. But if your question comes later, you can just ping me on Twitter. My email is sotobue@redhat.com. You can also send me there any question, no problem. And also I'm the author of these 4 books. So what we're going to see today? Well, basically, first of all, we're going to see a quick introduction of Kafka. Basically, because maybe it's like, okay, I'm a developer and I know a bit of Kafka, but maybe it's too basic, or it's like, oh yes, I know Kafka, it's a messaging system, right? So let's go deep a bit in Kafka, just like 5 minutes, so not so long. Then we're going to see what is change data capture. Probably here you might know exactly what it is, maybe not. So I think it's worth to make an introduction and understand exactly what change data capture is trying to fix. Then we'll see change data capture patterns, because as usually when we put, let's say, a new technology, it offers a big other possibilities, other patterns that we can just implement with change data capture. So we're going to see 2 of them. Of course, there are more. And finally, we're going to see Quarkus and Kubernetes, just to understand a bit the problematic of using Kafka inside Kubernetes. And finally, of course, a demo. So that's a really simple application. It's not a microservices architecture, I know, but you can just extrapolate to real microservice architecture, sometimes what we've got is something like this. You've got, for example, an order service, and you receive a request in the order service for an order, and then you insert this order inside the database of the order service, because remember that every microservice has its own database. But this data sometimes need to be propagated to, for example, other services, for example, the shipment service, or for example, the customer service. So we need to send this order to these other services. Or maybe sometimes you need to send this information to another database. Maybe you've got a data warehouse database there, right, that you're doing some kind of data mining, and you also need to insert this data inside this other database. Or also it could be an index database, for example, Elasticsearch. Yeah, we are storing all, all the order history there, so it's searchable. And that's fine, and it works. And the first thing that you might come to your mind to implement this is like, okay, I'm just going to do an insert to the order service database. Everything works. I commit a transaction, and then I send that data to the other database, to the other shipment service, to the other, for example, Elasticsearch database. And that's the first thing that comes to your mind, and it works. It's known as dual writes, because you are writing to two, or it could be multiple databases. And it works until it stops working, until you can start getting some inconsistencies. What's happened if I come in my data to my database, to the order service database, but then this shipment service is down, or the Elasticsearch that it's used for indexing the orders is down, or the data warehouse database is down. What do? You roll back this order because there is no order. Okay, you might say, yeah, it's an option, but you need to implement these rollback actions. Maybe you put everything in a big transaction. Yeah, it's another option, of course, but if you need to propagate this data to several services, several databases, you are blocking your database for a long time. Of course, you could say, oh no, I know what I'm going to do. I'm just going to accept this change, and if, for example, there is a failure when I'm trying to connect to shipment service, I will create some kind of polling process that is checking out of synchronization between this database and the shipment service. And if I detect any out of sync process, then this polling service will update the shipment service. Okay, yeah, there are multiple options, but you see that all of them are not perfect, complicated, requires you some kind of development, and well, you know that the polling systems typically fails. And what's happening if even you can think that what's happening if the polling system failed? It's down. Then you start getting a lot of out of synchronizations between data. So dual writes are prone to inconsistencies. Okay, you can write things in one database but not on the other one for any reason, and then you get inconsistencies. So we want to fix this problem. And one way of fixing this problem is using Kafka. How we can use Kafka to fix this problem? Yeah, we'll see it in a few moments, but let me first of all introduce you Kafka. One of the great stories about Apache Kafka is why it's named Kafka, right? Because probably most of you, before knowing Apache Kafka, you already know or knew Franz Kafka. And you might say, is there something related between Apache Kafka and Franz Kafka? And the answer is yes, there is a relationship. Franz Kafka, so the writer, was a guy that loved write, loved a lot. Not only the books, write a lot of letters for his family and so on. So loved writing a lot. It was all the time just write. Okay, and then the engineers of Apache Kafka, when it was not known as Apache Kafka, needed to decide a name for Apache Kafka. And they said, oh, how are we going to name this project? You know, naming things is always hard. And they said, oh, we know Franz Kafka was optimize it for writing. And Apache Kafka is a system that it's optimized for writing. So why not call it Kafka? So the reason that Apache Kafka is named Kafka is because of Franz Kafka. So at the end, more technical details of what is Apache Kafka. Okay, it's just another publish-subscribe system. Nothing new in this sense, right? It's just like GMS queues, ActiveMQ, RabbitMQ, and so on. It's just a system where you send messages, so you publish messages, you produces messages, and others subscribe to this system and just consume these messages. In the sense, it's more or less the same thing. But Apache Kafka was built having other things in mind that these other traditional systems doesn't have. The first one is that it's built having fault tolerance and a scalability by construction. If you start, I mean, we are not going to cover this today, but if you start learning Kafka and you start playing with Kafka, you'll see that a lot of the design decisions that were taken at the beginning was to make Kafka fault tolerant and prepare for scalability. So you can scale up, scale down all the system very easily. So it can handle a lot of events. That's one thing. The second thing, and for me the most important one, is that it's able to process all these events, all these streams in real time. So there is no more batch processes. If you think about in the past before Apache Kafka, we can think that we had a lot of events, and then by the end of the day, maybe at at 00 night, you just start a batch processing for process all the data that has happened during the day and provide some kind of maybe report or some kind of analytics. Okay, with Kafka, this is not required anymore. We can process all the data in real time. So as the events are occurring, we can just process all this data and provide some analytics. That's why Apache Kafka is a really good technical decision to take when we are facing these processing streams in real time. Just because we are going to mention this during the talk, with Kafka, we've got like, let's say, 4 important concepts. The producer is the one who produces messages. The consumer is the one who consumes the messages. No secret here. Then we've got the topic. The topic is where we store all these events. Okay, so a producer produces an event. An event is just a chunk of information into a topic. And the consumer consumes from a topic. But I know that if you already know Kafka, that's not entirely true. Even though as a developers, we always connect to a topic, internally, Kafka uses the concept of partition. Okay, so with Kafka, where the events are really stored are in a partition. I'm not going to extend more about this, but just keep in mind that as a developers, we always write and read from a topic, but internally, Kafka stores all these events, all these chunk of information that could be of any type into a partition. So that's Kafka, okay? If it's the first time that you hear something about Kafka, just keep in mind it's like a messaging system where we send events and we consume events from there. Okay, we've got Kafka, but it's just one of the pieces that we've got to try to solve the problem of dual writes. Remember, I want to store something in my database and into another database or into another service or another system. How can I automate this in a transactional way? Okay, this is how change data capture can help us. What is change data capture? The name itself, I think that describes a lot. It's just capturing database changes. So when, for example, we insert something into a database, when we update something into the database, when we delete something in the database, for example, I insert a new order to the order table, or for example, I update an order into the order table, then this creates an event and it sends it into an event stream. Of course, here I'm just setting that I'm just capturing the change in the database and I'm just populating this change into a Kafka topic. It can be a Kafka topic, but it could be another messaging system. It could be any other messaging system. It could be RabbitMQ, ActiveMQ, GCP queues, and so on. It doesn't matter. In this example, I'm just providing you with Kafka, but it could be any other system. And what I'm going to show you today, even though it's for Kafka, it works for any other system. And then when we've got this change into the event stream, so I inserted something into the database, then automatically you will see how the this change data capture pattern just captures the event and put it into a Kafka topic. Then we can have a lot of other systems consuming these events, and this happens automatically. So every time that I insert something into the database, all the systems that are subscribed to this topic are going to receive this data. And it could be, for example, another database for data replication. So I've got a database, the real database, and then I've got a pre-production database where I do some kind of test. So maybe I want to populate data between databases. So I can just make or use a process that consumes data from the topic and put it into the database. Or it could be other services. Maybe you've got another service that needs to get this data and do something. It could be a Go application, Quarkus application, Spring Boot application, whatever. It's another service. Or maybe it's a serverless thing. You've got there some kind of, serverless process running, and it's just scale it to 0. And when I get it an event to this topic, this process is automatically wake it up and process this event. Maybe it's, as I said before, Flink, Elasticsearch, maybe Kafka Streams if you want to process the data at real time. Or even you could update or invalidate distributed caches. Sometimes we want to, when we've got applications that are distributed across the globe, we want to have some kind of caches to avoid, the data traveling around all the time. But how we maintain these caches updated? Well, change data capture can help you as well. Okay, so we know what is change data capture. We put it here. And of course, here, there is a missing piece, and it's who are listening for a change in the database and publish the change into Kafka topic. And this is exactly what is Divisium. Divisium is a Kafka connector, okay, that basically taps into the database transaction log. For those who don't know, usually when we do an insert into the database inserts the data into, let's say, this, this tree structure, so it's put it inside, let's say, the final destination, but also has one thing that it's called transaction log. This is a place where it stores all the things that are happening to the database. So if there is an error in the middle, the database can recover. So for this recovering, it just creates a transaction log. Then Divisium is just connecting to this transaction log. It captures all the insert, update, and delete events. Then when it has these events, it just propagates these to all the consumers. For example, Elasticsearch, could be InfiniSpan, could be the data warehouse, and so on. And it propagates these events or consumers using Kafka and Kafka Connect. So basically, Divisium just connects to the database, to our service database, captures the changes from the transaction log, insert, update, delete, and put them inside Apache Kafka. Then, if we are subscribed to this topic, this change will go to the consumer, right? So that's exactly what Divisium is. As I said, Divisium, it's just a change data capture platform. It's based on transaction logs. So there is no polling system, just doing select from this table, select from this table. No, it's not working in that way, just using the transaction log, which is better. Also, transaction logs are written when the transaction is coming. Okay, it means that we cannot get out of sync data. When the transaction is committed, the transaction log is written, and Divisium then will propagate the change. Also, it supports snapshotting, filtering. Sometimes you do not want to propagate all the events, so sometimes you want to propagate just some kind of event, so you can filter them. Also provides support for the snapshotting. Basically, what's happened if you've got a really long data to be transmitted from database to another system. We cannot block that database for a long time, or maybe not all data is in the transaction log. Then you need to do some small chunks of process data, right? So you do a snapshotting. Also, it has support for outbox support. Outbox pattern is a really nice pattern we're going to see in a few moments to solve this dual rights problem. It provides a web-based UI. It's open source, so you are free to use it. I think that it's Apache license, and it's been proven to use in large production deployments. As far as I know, there are a lot of them, but for me, the biggest one is, for example, Ubisoft, Zalando, Shopify, Vimeo, or Reddit. So big companies are already using Divisium as is change data capture platform. Which connectors has Divisium? So we've got the database, we've got Kafka, okay, but which databases works Divisium? Now it's in a stable with MySQL, Postgres, MongoDB, SQL Server, DB2, Oracle, and of course, you can think, for example, MariaDB as well, because it's just, it's similar, it works. CockroachDB as well, as uses the Postgre driver, so it should work. And then there is an incubating VTs and Cassandra. So one of the things that I want you to notice here is that also NoSQL databases like Cassandra or MongoDB are also supported by Divisium. Maybe some of you are saying, okay, and it supported other things rather than Kafka. And the answer is yes. Divisium can work as a Kafka connector, or it can run as a Java process, and then you can implement there the messaging system that you want to send that event. So Divisium is just a piece in the middle that just captures the events that are happening on your database, and then by default, let's say, if you implement it as a Kafka Connect, sending to Kafka, but you could also send it to other systems. What is, I mean, that at the end it's like, okay, Divisium is detecting a change, that's fine, but how does this change look like? And at the end, this change is just a JSON file. Basically, it just, you can see, for example, the before and the after. So it's saying, hey, this is an update. Before, we've got this information, and now we've got this information. So you've got the before and the after. Of course, if it's an insert, the before section is empty. And if it's a delete, the after section is empty. Okay, but it offers this information. It also offers some information about metadata of the table. So where is this this database? You say it's database Postgres, schema public, table customer, the transaction ID that, which transaction created this data inside the database, and also the up is the operation type. You see that this is an U, it means that this is an update. Okay, so it also gives you the information about, hey, someone has done an update to this table in this schema, in this database, in this transaction ID, and also give you the time. when, or the timestamp when this operation has occurred. Okay. So now we've got Divisium that reads from transaction log events, so operations that are happening inside the database. It's sending the event to a Kafka. Great. What this infrastructure, if you will, enable us? Which patterns can we implement? And the first one is the outbox pattern. As I said at the beginning, we want to solve the dual rights problem. And that's exactly what we're going to see. Basically, as I said, I've been saying all the time, services need to update their databases, and also maybe they need to send messages to other services, like the order service, to the shipment service, to the customer service, maybe to the Elasticsearch database, data warehouse database, wherever, right? And they need to do this, and we want to make it consistently. So we do not, if we have an insert in this database, we also want to have this insert to this other service, to this other database. And what you're going to, or what we need, is the outbox pattern. But basically, it's using Divisium and Apache Kafka to send the events from one service to another one. So let's say the more in detail the outbox pattern. We've got the order service. We get it a new insert, new order. It goes to the service, and the service just sends the insert to the database. And okay, in a single transaction scope, so in a single transaction, it's just creating an insert to the order table, an insert to the order line table. So it's just creating two inserts, and that's the business of, or the table of business of our business, the tables of our business. Okay, so it's just the tables. But the outbox pattern tells you, okay, insert a new table that it's named outbox. And in this table, you're going to insert what do you want to transmit to the, or you want to react, the events that you want to react. So you don't want to react to the events of orders. You don't want to react to the events of order lines. You want to react just to the events of the inserts or updates or deletes that are happening in the outbox table. So my Divisium system are only reacting to outbox inserts, deletes, and updates. The outbox table, it's then you can put your outbox table in something like this. You just get, for example, an ID. The aggregate type, you say, okay, this is an order. The aggregate ID, you can put it an ID, and you can even put here an event type. For example, an order was created, and then you put the payload, and the payload, of course, could be anything you want. In this case, it's a JSON. A JSON document. So we'll see in the code, but when I insert a new order, I do an insert to these two tables, and then I do an insert to the outbox table. But all these events are in the same transaction. When all this transaction is committed, transaction log is changed. The Divisium will detect the change in the outbox table with all this kind of information, and it will send this this event to, for example, the order events topic. Then we can have the shipment service, for example, just consuming consuming from the order events topic and get this data and do something. What is important to notice here is that all this thing happens in a transactional way, because here it's in a transactional scope, and Apache Kafka, it's working in a reliable way, which means that when you send the event here, the event is been there. Maybe a shipment service is down, no worries. When you wake up, shipment service again, it will consume the event, so no problem, the event is not lost. And also, what's happening if change of Divisium is trying to insert something into the Apache Kafka, and Apache Kafka is down? It doesn't matter. The Divisium will be there waiting, and when Apache Kafka is up and running again, it will send all these changed events. So it's really nice way to avoid inconsistencies. The system automatically recovers. Then, of course, as I said before, we could just have Kafka streams, Apache Flink, or whatever to process also this data. and provide even more information. So we can just detect the change, put it into a topic of Apache Kafka topic, process this data with Apache Flink, for example, or with Kafka streams, and then provide these manipulations to a Kafka topic. So this is an enriched order event because we are changing data and then send it to the Schema server. So that's another thing that you can do with outbox pattern. Also, we've got another pattern, which is the strangler fig pattern. The strangler fig pattern basically helps you on gradually evolve from old systems into new systems. But one of the great things about this pattern is that it's not like a big bang, right? It's not a big bang controller. It's not like, okay, you've got this monolith application, you see, Spring 3 with Java 6, with owners component, pet component, visitors component, batch component, all a monolith and the MySQL database. And suppose that we want to move this to a microservice architecture. We can just split down all the services and just deploy them and see what's happened, or we can do that gradually. Okay, so suppose that I've got this monolith and I want to change the owners component to use Quarkus, Java 11, and use MongoDB database instead of MySQL. How we can migrate from this solution to this solution without a big bang, coexisting both options, and if we find any problem, that we can always roll back to the previous version. This is a strangler fig pattern, and it's using change data capture approach for doing it correctly. That's the original application. Okay, a monolith application, a web page done in Spring 3 and Java 6 with all these components there and MySQL. Then the first thing that we need to do is add an Nginx proxy. It doesn't matter, HA proxy, Envoy proxy, whatever. We need to put a proxy there and say, look, all the writes goes to the monolith application, all the reads comes from the monolith application. That's the first step. See here, we are not changing anything, just putting Nginx proxy. All should work as expected. Then we're going to use Divisium. We're going to put Divisium here for listening all the changes of where? Of the owners component, because the owners component is the one that we want to take off this monolith application. So we're just going to listen all the changes of the owners table, put it in the Kafka topic, and then we're going to put MongoDB for consume this event. So at this point, all the writes, all the reads goes to the monolith application, but the data, it's replicated to MySQL and automatically going to MongoDB. And see that it's automatically. We do not need to change anything from the monolith application because it's the Divisium who detects the changes on that table and sends the changes to the MongoDB. So it happens, we are not implementing nothing, but now the data is in both places. Now that the data is in both places, we can deploy the owner service with Quarkus and Java 11 and change something. For example, put that all the writes goes to the monolith application. See that when I write here, it goes to MySQL, Divisium propagates the change to MongoDB, but all the reads that are from the owners component are going to come from the owner service, the new owner service. And the other reads, the batch component, visit reads, batch reads, comes from the monolith application. And see that now, if you do this and you detect any regression in owner service, you can always say, oh, let me stop it, right? You can just remove this and nothing happens. Well, nothing happens because I'm all writing here and I need to change this to all reads again to here, and everything works as expected. When you start seeing that everything is working as expected, then you can make that the owner reads and the owner writes goes to the owner services, and then you can just remove the owner's component. And there is another thing. What's happening if we want to roll back then to monolith application because I detect any error? When I just sending the writes to the owner service, I also need to propagate to get back the changes from the MongoDB to the MySQL, because now the writes are happening on MongoDB. But if I want to have both databases in sync, I need to propagate again the changes from MongoDB to MySQL using, for example, the MongoDB source connector and the JDBC sync connector. So now we want to make Quarkus and Kubernetes because, okay, we've got these two patterns, change data capture, strangler fit pattern, outbox pattern. I want to put these into the Kubernetes. Putting Kafka in Kubernetes is hard, and I recommend you to use Streamzy because Streamzy is just a Kubernetes operator that helps you on deploying or provision a Kafka cluster into Kubernetes in an easy way. It's just, you know, install in Streamzy, and when you've got Streamzy installed into Kubernetes, Streamzy is an open source project. You can start create this kind of Kafka YAML file, and you said, hey, I want to create a Kafka cluster of version 2.4.0 with 3 replicas. You apply this YAML and done. You've got your Kafka cluster up and running in Kubernetes. Then what we're going to see this example, the order service and the shipment service, and how the outbox pattern works. Okay, as you might know, Quarkus is the superatomic Java framework that helps you developing enterprise Java code and be able to compile to native library binary file using GraalVM. Then remember that if we are going to create the outbox pattern, we need to create an outbox table. You remember here that it's over here. Let me find it in a moment. Remember when I explained it, the outbox pattern, we said that we need an outbox table. So we have the business tables and also the outbox table. In Quarkus, in Quarkus is as easier as creating this class. You create a class. This is the outbox table name, implements exported events, and then here you put all the fields that you want to store. They are generic fields. You can put whatever you want. In this case, I put the customer ID, a JSON node to store the JSON content there, and also a timestamp. And then I put it here, the type, which is when I create an invoice. Then, in my transactional method, the method where I want to add a new order, I do entity manager.merge of the order. So I just install the order, and then I just do event.fire invoice created event of order. So basically, I'm just inserting this data inside the outbox table with just doing this. And since everything is transactional, all these two inserts are going to happen in a transactional way. Then, when these changes are in the outbox pattern table, Division will react and send the event to the shipment service. This is how you can start Division. We're using a Docker Compose, and this is how you configure Division. You basically, the important things here is, okay, I want to listen changes. Where I need to listen the changes. Okay, I need to do the host name of the database, the port, the user, the password, the DB name, also in which tables or which schema I want to listen for changes is the inventory, which table, the inventory.outbox event, and well, and then you hear some transformations, but that's basically all the things. Now, let's do a Docker Compose app, minus remove Orpheon. So I'm just going to start the project again. Keep in mind that the code is here. So if you go to github.com/lord-of-the-jars/division outbox, which is here, you see all the example. Order service SB is order service Spring Boot. Here, order service is the order service in Quarkus. Shipment service is Spring Boot. Shipment service, this is the division information and so on. Here, well, just here because it's the file. I've got here a file with all the instructions. Okay, now if I do Docker PS, you see that all my stuff is up and running. We've got Kafka, we've got Postgres, we've got the shipment services and so on. Okay, now let me configure Division. So I'm just going to configure Division. Basically, what I'm doing here is sending this file, okay, to Division. So I'm just saying, hey, Division, I know that you are up and running. Just connect to this PostgreSQL database, to this table, the outbox event data table and start listening for changes. So let's go here. I'm going to do this. Okay, you see that says, okay, everything is everything is configured and so on. Well, there's some kind of information done. And now I'm just going to do an insert. And basically, this is creating a new order. I can go if you want. It's in sources, main resources, sources, main resources. You see data, create order request. You see that basically I'm just it's this, I'm creating 2 orders for the customer 1, 2, 3, division in action and division for dummies. I'm just creating these 2 orders. So I'm going to run them. I want to insert. Now, what's interesting here is that I'm inserting data into a database, into the PostgreSQL database. So see that if I do docker ps, where is the database? Is here. Docker exec -ti /bin/bash. I'm just inside the database. Now, let me go. I can just kind of log into the PostgreSQL and just log it. And now, if I, for example, I do a select from purchase order, you see that this is the purchase order. I just ordered the customer ID 1, 2, 3. Also, if I go here, oops, 1 second, it's this. You see that I've got the inventory order line is division in action and division for dummies. So these are my business tables. Then what's happening if I do a select from the inventory? Remember that when I did the insert in the transactional way, I inserted purchase order, order lines, and also outbox event. Remember that I did this here when I did this event fire. If I select this table, you'll see that there is 2 new entries in the outbox event, 1 for order and 1 from customer, and this is the content of the invoice for the customer, and also the order of the books that I've just ordered, which are division for dummies and division in action. Okay, that's the database. That's all the things that I've done. I've not done anything else. I've just inserted some data inside this table. Division is running, and since Division is running, basically it just detected that someone has just added some entries into the outbox table. Now, if I'm just going here, this Apache UI, you see that there are some topics. You see that there are some topics, customer.events and order.events. So what I'm doing is the events that are of type customer goes to the customer event topic, and the customers of type order goes to the order topic. For this reason, I've got here 2 topics. And if I, for example, go into the order events, you see that there is 1 message, and this message, as you can see here, it's the I can do this. Let me go find a JSON formatter. Let me look. Here's the yeah, we can do validate. It's okay, doesn't matter. You see here that basically in the Kafka topic as an event, I've got all the information regarding the order. And the key point here is that I am not inserting anything directly to Kafka. It's Division who is doing all this stuff. And Division is the one who takes care of maintaining Kafka and the Kafka topic and the database in synchronization. Okay? And then if you consume from this topic, you'll get it, all these dual writes without inconsistencies. And that's all the things that I wanted to show.
Hello again, Alex. Thank you so much for the interesting talk. Hope you had fun. All right, are you ready for some questions?
Yes.
Perfect. First one. If we want to implement the CDC part by ourselves, not using Debezium, then which challenges should we keep in mind?
Yeah, basically is that you need to read data from the database, okay, because you need to capture this data from the database, and you should do it from the transaction log. And that's one challenge. The second challenge is how you maintain all this synchronization. I mean that you can start reading from the transaction log, and then, oh, there is an error in my process of change data capture that I implemented my own. And at which point I left that processing, and I need to, when I just start again, in which point I need to continue consuming. So you need to store all these things. And this is something that Debezium is provided for you. Keep in mind, as I said during the talk, that you can use Debezium as a standalone, as an embedded system. You do not need to use Kafka. It's not mandatory to use Kafka. You can just use any other messaging system. And you can only use Debezium as a way to capture the data changes.
Right. Thanks for that answer. We got another question. On outbox pattern, what happens if Debezium is down, or the DB transaction fails, or the TX log gets lost, maybe?
Yeah, well, if the transaction if there is no commit, so there is a rollback, it doesn't matter, because since Debezium is just reading the transaction log is written when the transaction is committed. So you can be sure that what you read from there, it's real. If Debezium is down, well, at some point, Debezium will come back again, and Debezium knows at which point which data has not been transmitted yet. So it will start reading and send it to there. That's the thing. And what's happened if there is no transaction log? This is when snapshotting comes into the scene. Basically, it's by doing a select on the tables and just populating data using the select instead from the transaction log.
Right, thanks for that as well. We got another question. How about to get the database changes before it goes to a database? If I implement a CQRS pattern, maybe?
Yeah. Can you repeat the first part of the question? Was that?
Yeah. How to get the database changes before it goes to a database?
I don't know, because here it's like, it's like, I understand, but then maybe there are other tools to make this, but in the case of the talk, on the scope of Debezium is when you commit something into a database, then it's when everything is fired, right? It's when all the party starts. The party starts when there is something in the transaction log, not before.
All right. Another question. How do you create your nice looking microservice diagrams? Is there a specific tool, or is it a customized design?
No. There is an online site. I think it's called X. I can find it. Wait. I'm just going to share my screen so you can see the here. It's this one. It's Calidro. Okay, it's that one. And then you click it here, and you say, oh, I want to use a Kubernetes. Okay, you put it here, Kubernetes, and then I want to use, I don't know. There's a lot there. This the Go one.
Okay, so you don't have a designer dedicated.
No. I do my own. Yeah.
All right. But nice tool. Didn't know of that. Thanks for sharing, Alex.
Thank you.
Another question. Instead of writing to the outbox table, what are the difficulties we can face if we publish directly to Kafka topic after the transactional layer of the code?
So you mean it's like without using Debezium? Because if you're using Debezium, you can just hook to the outbox table or to any other table. So you can just hook Debezium directly to the order table. So I don't know, that's the question. If it's like, okay, no, I just want to put, do a transaction between sending to the database and then to the Kafka. Well, if Kafka is down, then if you get an error, then all that process will be rolled back, and maybe you could just say, if the order is in the database and I just put this to Kafka, maybe it's not mandatory to put it to Kafka. I can wait for, this eventual consistency, right? Or eventual inconsistency, and I can live with this. But if you make it everything fail, then you will get an error that maybe it should not be that hard, right? So it was like, okay, there is an error in Kafka. I'm just going to commit to the database, but later on, I know that Division will take care of putting this into Kafka. If you are not using Division, then you will need to do some kind of polling system or just roll back everything.
Good. Alex, thank you. I know that you are also a very experienced developer. Maybe you want to share with us how your development journey began in the first place and how you got to the point where you are now.
Well, I started really. After my first year at university, I started, as intern in a company just developing. And one of the funny things is that I've been all my life working in Java, developing in Java. Right? So yeah, nowadays I'm still in Java, and it's funny because if you don't know, the Java Enterprise spec was released at 1999, and I started using it at 2001 or 2001, 2000. I don't remember exactly. So it was really new on that technology. Yeah, so it's more like, I was here in the beginning, just, coding a lot. And also with the time, at the time, I remember going to a conferences and said, oh, if these guys are sharing the knowledge, I can do as well. And I started just submitting to the conferences and see how it was going. And yeah, I was started being accepted. But yeah, until today.
All right, sounds nice. So you were an early adopter and you stayed dedicated to Java.
Yeah, well,
that's also
nice. But it's true also that, with the age, you are start, let's say, I would say that until Java 8, I was super keep updated, right? Oh, there's no version of Java. I'm going to just see the release notes, learning everything, all the things. And now it's like, okay, yeah, you're learning the big things, and then yeah, you start. You're not keeping the same pace. Also, that it's a good news for the Java ecosystem that now they release pretty often, so it's harder to stay updated with all the things. But yeah, I hope everything is changing. Also, now we've got a lot of options. Not just Java, it's also Kubernetes. Then you start Kubernetes is Istio. There is Kafka. There's a lot of things that you need to keep updated as well. So the life is more complicated than before, where we only have an application server and a database and done.
Yeah, that's true. But Alex, this wasn't the first talk you had at one of our events. You also talked at the World Congress 2022. Maybe do you want to share some of your experiences from last year's Congress with us?
Oh, yeah, I would say that any developer should go there. And I'm saying, and because it's huge event, huge. It's super big. It's for example, here in Barcelona, we've got the Mobile World Congress that's super big, but it's for mobile and also it's a lot for business and so on. But if you go to WeAreDevelopers in Berlin, there it's the same thing. It's maybe 8,000 people, 10,000 people. Big people. There are a lot of and just developers developers, DevOps, but it's not a business. Or it's not focused on business. You're not going to get business there. You're getting depth, experience, and also for a lot of languages and so on. Super well organized, and that's the truth. And this is what I want to say.
All right, thank you so much, Alex. Thank you also for the amazing talk and for the very cool Q&A session. Hope to see you soon, and wish you a nice rest of the day. Bye, Alex.
Thank you. Bye.
So if you are also interested in making the same experience like Alex did last year, maybe go to worldcongress.dev to get further information to our upcoming World Congress 2023, which returns in July as an in-person event in Berlin. And there you can also claim your tickets. And before we start before we go on to a quick break, Also, quick reminder, together with our awesome partner Deloitte, we're doing a giveaway. You can win a MetaQuest 2 VR headset just by scrolling down the page, clicking on the button, and you're good to go and have joined the raffle. And now we'll go in a short 5-minute break. Stay tuned.
People should go to WeAreDevelopers because there are a ton of talks in a lot of different areas. You know, if you program, if you're part of the world of programming, this is the place to go.
I think this is a very good and diverse event. And then you also have a chance to talk to different companies and different people to get to know the industry.
So welcome back, everybody, and right back to Java. Quick reminder, if you just joined in, you can also watch the whole session afterwards on demand on our live page and on YouTube. So, and now to the next speaker of today. He is technical architect at IBM iX, has a background in performance tuning, coding, and also mentoring. Welcome, Jakov.
Thanks, Ben, for the introduction. Nice to see you.
Hello, so happy to have you. How are you?
Yeah, I'm quite good. Yeah, thanks for asking.
Perfect. So, would you mind telling us a bit about what we are going to learn from you today?
Sure. So there's quite a big hype around ChatGPT. I was also quite curious to see what's going on in the kind of coding space. And but there are not many resources around Java, so mostly Python, mostly front end. So I was quite curious, and I prepared the presentation for you. I think it would be quite interesting for all Java developers. I prepared basically the benefits, also some limitations, and at the end, you will see who can benefit the most.
All right, so very hot topic. You got my full attention, and I would say stage is all yours.
Thanks a lot. So for everyone, my name is Jakov Semensky. I'm a technical architect and head of at SAP CX Croatia. You can reach me at my company address or find me on Twitter or LinkedIn. I'm located at IBM iX in Studio Zagreb. So in this talk, I promise to reveal the most compelling benefits of using ChatGPT, the potential limitations to be aware of, and specific scenarios where ChatGPT will be most effective for you. By the end of this presentation, you will have knowledge and the understanding of capabilities from the perspective of a Java developer. But first, let's understand what is ChatGPT. Just a bit more than a month ago, OpenAI released ChatGPT. It's an AI system that has been released on November 30th. It is trained on massive amount of text data that has been fine-tuned for human feedback. It makes it possible for ChatGPT to answer follow-up questions, admit its mistakes, challenge incorrect premises, and also reject inappropriate requests. It has been built upon GPT-3 model, which has around 175 billion parameters, while we expect for GPT-4 to have 600 times as many as GPT-3. Parameters basically are a measure of the model's capacity and are used to store the knowledge learned during the training. Basically, the more parameters a model has, the more information it can store and the more complex tasks it can perform. This will allow ChatGPT-4 to process and generate text with greater accuracy and fluency. However, we don't know when we can expect the release of GPT-4 language model yet. ChatGPT is already a visualization that could completely change how we do things. And it has been covered a lot in press and in social media. It can write jokes, it can write college essays, create games, it can explain concepts in multiple levels of difficulty. In just 6 weeks after release, it has been evaluated at $29 billion. Which means OpenAI valuation more than doubled from 14 billion to 29 billion in just over a year. Keep in mind, it took Netflix 3.5 years to reach 1 million users, Facebook 10 months, Spotify 150 days, Instagram 75 days, and ChatGPT only 5 days. Every other hour, the website is not available because of the amount of activity. And no wonder, with such a huge growth, it's estimated that ChatGPT burns around $3 million a day just to run it. Here are just some examples what ChatGPT can do. There is one of the most popular tweets I found on Twitter. is from a software engineer who asked ChatGPT a hypothetical question from point of view. You are a software engineer at Twitter. Elon Musk asks you what you've done this week, and you've done nothing. Frantically, you open ChatGPT. Elon Musk just sent me an email saying, I'll be fired from Twitter if I don't get him 3 examples of code contributions I made. Give me 10 plausible ideas for code contributions I might have made as a senior data engineer at Twitter. And in just 3 seconds, ChatGPT gives out 10 plausible answers. Develop a machine learning algorithm, implement a real-time pipeline, create a new data storage, develop a new data visualization tool, and so on and so forth. Let's go with option 9. What is my contribution there specifically? Make it really in the weeds with lots of imagined technical detail. Elon doesn't know how this works, but it has to be plausible. Also make sure the contribution is small enough in scope that I could realistically have completed it within a single week. And he gets his answer. And then he replies back, okay, now give me an overview of the code I wrote for this with commentary and precise fabricated numerical performance metrics. And he gets the code. Yeah, quite funny. And at the end, he says that it's quite receptive to constructive criticism. So he asks ChatGPT, okay, like it, I really do, but few points of feedback. The code isn't nearly complex enough. Can you do more there? And some cost and some enum maybe. The language should be way more technical, randomly referring to things in academic machine learning terminology. We want Elon to think I'm smart. You don't have to point out obvious stuff in the commentary like nothing that something is printed to the console. Okay, now let's try again from the top. As you can see from this example, it's quite an awesome tool. Also, Elon Musk itself tweeted, ChatGPT is scary good. We are not far from dangerously strong AI. But why should you care? There are many bold claims that ChatGPT can make developers 10 times faster. Or AI will not replace you, but the person AI will. Is it a potential to significantly improve the efficiency and productivity of developers? So I put the tool to the test. I tried follow a couple of scenarios related to coding, something like code snippets, generate tests, to see if it can show project files, deployment files, invoke REST calls, refactor, run our application, show UML diagrams, or show sequence diagrams. Also, from the perspective of someone just starting out with Java, or is aware of some basic concepts, can he use ChatGPT for learning? So let's start with the coding session. I won't be using live demo because almost after 10 minutes of usage, I reached the kind of some limit, and sometimes it's really laggy and slow. Therefore, I have pre-recorded sessions of this scenario. So in first scenario, I wanted to create an app that returns user valid credit cards. Let's imagine they are saved in database, and they should come out masked. So can it code, and can it include tests, and can it refactor? So I open ChatGPT, and I write, create Java controller that gets user valid credit cards from database and return them masked. Okay, so first I got some import statements. Then I get the credit card controller. Okay, so also it assumed that the path for this would be /valid credit cards. Okay, let's pause for a second. We can see It produced the method. It uses credit card depository to find all valid credit cards, which is nice. He also uses for loop and then seems to mask it. Seems like a working example. And it also does a thorough explanation what credit card repository does. And also that it's better to use tokenization or encryption. So I asked him, okay, as an input argument, use path variable user ID, because maybe my first prompt was vague and he didn't understand he has to get credit cards from a user, not just any credit cards. And he did so. We could see he changed it. He listened to my prompt and then he added the new path variable, and he now is invoking call to JPA interface with user ID. However, I'm still not happy. I would like that user ID comes first and then valid cards. Of course, it would be better that it's maybe users/user ID and then /valid credit cards. And ask him to use regex to mask credit card information. And for the sake of the demo, to avoid import statements. Seems to be right. So he did already refactor it. He used regular expression, so this worked out fine, and he did return the credit cards. Now I'm not quite happy. He's using for loops instead of Java streams, and I'm not happy that this code is embedded in the controller. We know that this is not a good separation of concern. So I asked him to extract the code into separate interface. So let me pause for a second. We could see right now, yeah, he's using streams. He's mapping a card, but he's mapping by calling masking service, collecting and returning a list. And he already implemented masking service implementation. So this seemed to work out well. Now let's write some tests. Create unit tests for controller and masking service, but don't write import statements. So he's creating a credit card controller test. Gave few examples. And he's expecting to get masked result. And he's using basically Mockito as a framework to mock the behavior of a mocking service. So we could see he created a unit test. And now he's doing the same for masking service. So he split it into card, expected result, and then the final result. Now we could, of course, improve this more and prompt it, okay, maybe use BDD Mockito and maybe use a CertJ library to kind of make it more cleaner. But you get the picture how you can use prompts to basically instruct it what to do. Now I want to do integration test, so I asked him, okay, create a wire mock test for the same class. So let me speed up a bit. Okay, so yeah, and he was able to do that. He created a wire mock rule to work on port 80, 89. And he also created a stop, so it returns me 200 okay status HTTP status code with the content type application JSON and also a list of credit cards. Okay, and I asked him, okay, create a credit card controller. You create a test for credit card controller using Spring Cloud contract. So he did that as well without any issues and provided some explanation. Now I notice, it seems that he's returning just the strings. I'm not quite happy with that. I would have expected that he returns an object. And also noticed that I used user ID / valid credit cards, and now he changed it here for some reason. So this test for sure would fail because my controller, as we saw earlier, was user ID / valid credit cards. So now we seem to have found a bug in his test, but okay. We just give him feedback. And I don't see how the get valid credential card response JSON looks like. And also you don't need to write imports explanation. Yeah, for the sake of the test, let's not have explanations. So let's speed up this a bit. Okay, we can see he corrected the path. Oops, sorry. I seem to have gone a bit too fast. Okay, and then we could see how does the get valid credit card response JSON looks like. But like I said, I'm not happy. Let's assume database returns credit card ID, name, and the number. And from a controller, we need to get the same data, but with masked credit card. How would our test change? Write just the code. Okay, so we got some sample credit cards. That's nice. We got our object. We have our mocking. It's even translated to given when then. I don't know if I even asked him that. I didn't, but that's nice. And yeah, we have our test ready. Again, make a Spring Cloud contract test. Let's speed up a bit. Cool. And I told him, okay, write me get valid credit card JSON. He didn't actually write me as a Java code. I would have expected to see something like a method name. So he missed to do that, but okay, nevertheless. And that's it. In one of the examples, I got a hard-coded response in a string. However, it was basically not using the Java text blocks. So I strictly, okay, convert this to Java text block, and he was able to do that. So we went through the coding example, but can it produce UML? So in this demo, I asked him to create a library application that supports borrowing technical books that are saved in database, use Google as an out provider. And the question is, can we see project files? Can we get UML diagrams, sequence diagrams? I mean, it's just a chatbot, isn't it? I don't know. Let's see. So here I prompt him, create a Java application that allows borrowing technical books to user. Admins have dedicated role which are able to add books, remove books. Users and admins can log in by using Google as an out provider. And show me directory structure. Okay, some corrections. Use Java REST application based on Spring. So first he gives me an outline, what he would do. Create a Spring Boot project, create a book model class, a book repository, user repository, so it makes sense. All our CRUD repositories, create an out controller, makes sense, create a book controller, and so on. So let's speed up a bit here. Admin controller. So these are the things he would do, but he didn't give me any code. And he gave me a directory structure. So this is how usually our Java Spring projects look like. And it explains what is under source main Java. I don't see, however, test. In one of the examples, I even got a test directory. So ask him, write me an UML diagram for tool Mermaid. Here is an example of how you could create class diagrams using Mermaid. And it just spits it out. Keep in mind, it wasn't easy to reach that point because, first of all, you have to be aware, okay, what UML syntax ChatGPT is aware of. So you kind of first have to prompt him for which UML tools are you able to write syntax. Then you get a list of 3 or 4 tools, and then you can. Then I found out, okay, Mermaid is a supported tool. So I got the output. Seems about right. Okay, then here are the relationships at the end. You will always get at the very end a disclaimer, something like this is just an example, this is not the real code. You just basically ignore that, copy the code, click on the Mermaid Live editor, paste it here, and we seem to get an UML diagram, which is quite awesome. So we seem to have everything. We have a book controller, admin controller, a repository, out controller. So all the classes that ChatGPT mentioned. But let's go one step beyond. Ask him, okay, can you create me a sequence diagram? This is a bit speed up version because it takes a while to generate. It seems to be working. So let's just copy again, paste in the same tool. And we get our sequence diagram. So we could see we have our user, admin, book landing system, Google Auth, util, security config, user repository, book repository, loan object, loan repository, and also method calls. And yeah. Now as a last step, asked him, okay, where can we deploy it? And now I got some options where kind of we could deploy it, because I wanted to also find out, can we get a script for deploying it on AWS or, I don't know, Microsoft Azure or Google Cloud. So here you get just the deployment options. Okay, I asked him, okay, create an AWS cloud formation file for this app. And he says, okay, I'm sorry, I'm not able to create AWS cloud formation file for this application. However, I can provide you with general overview of how you could use AWS. Also, so gives me detailed instructions. I think we can skip this part. But he doesn't give me the actual file. Eventually, I also try to see, can we create an UML diagram within ChatGPT? So I prompted it, show UML diagram between user and loan. So before I asked him, okay, write a syntax for Mermaid ID, and here we changed it and said, okay, show me the UML diagram. And it prints out the UML. However, it's quite limited due to the space, and I got him mostly to do UML diagram for 3 classes, so it cannot do more than 2 or 3 classes. And of course, this is not a nice interface to kind of have or play with UML diagram. But it's still awesome to find that it works. Okay, so I'll speed up a bit. Also explains the relations. Okay, let's go to the next slide. As I told, as you have seen in the demo, I tried to kind of get from ChatGPT a CloudFormation file. I failed here, but in the earlier session that I tried, I was able to do that. So I prompted ChatGPT, create a CloudFormation file for this app, and also write Helm chart if I want to deploy it to Kubernetes cluster. And it basically gave me an example, and it even inserted book landing app at the right place. It recognized its Java application. It also for Helm chart. I'm not a expert in Helm charts and have never written one, but okay, this template looks like a good starting point. Now the question is, can we run our app? I mean, of course, initially I would have said no, but let's look at this example. I mean, it's just a chatbot. So I asked him to create a REST application that persists list of conferences in MySQL database, exposes get and post mapping, provide curl request, and also if we can run it. Then again with the prompt. Create Spring REST application that persists list of conferences in MySQL, exposes get and post mapping, and provide curl request examples for both mappings. So again, we get example, what we should do. I think we could skip that. Okay. It also shows me how database should look like. So he already creates an SQL script to create a table. It also shows me how we need to configure property files for a Spring application, data source, username, password, our entity, so conference, and our repository. So it extends JPA repository. Of course, it doesn't need to implement any methods. There's nothing particular about, nothing custom about this one. And finally, it creates conference controller. Okay, seems quite nice. Similar to our first example. So we have our get mapping and we have our post mapping. And it says once our application is up and running, you could use this curl request. First one is to get the list of conferences, and the other one is to create new conference. So I was already quite happy with the results, but the question is, can we run it within ChatGPT? Okay, so I prompted the following. I want you to act as a Linux terminal. I will type commands and you will reply with what the terminal should show. Imagine we are in conferences directory, which contain full application code. Imagine there's MySQL database already running with conferences table. I want you to only reply with the terminal output inside one unique code block and nothing else. Do not write explanations. Do not type commands unless I instruct you to do so. When I need to tell you something in English, I will do so by putting text inside curly brackets. Like this. My first command is password. So just a second, I accidentally went to the beginning. Okay. Now keep in mind, for every, when I ran this test, it was quite unresponsive. So sometimes you have to wait for not 3 seconds, but for 3 minutes or 5 minutes or 10 minutes. Cool, so it ran the pvd command, which basically shows where it is in the directory. Okay, let's try to start our application. Maven clean Spring Boot run. And we get the console output of our application, which is kind of starting. And it says com example conferences. Okay, also uses conferences here. Nothing to compile, all classes are up to date. And this is the best part. It shows the Spring logo. Okay, so finally our application started. I copy the curl request, change it to, let's say, WeAreDevelopers conference. I want to insert it, and let's assume it's in Berlin. I think it is somewhere in June or July. Ignore the dates. What's our response? We kind of, okay, we waited. Okay, we got the response. Seems that it has been inserted. Okay. Let's insert another one. So I said, okay, insert Devox UK in the location UK. Now let me get the list of conferences, and we get the list. We get a JSON file with 2 conferences. Now I'm not happy with the result because I would like to have it prettified. And then it says, okay, yeah, but you have to use JQ command. So use the JQ command, call it again, now get it in a nicer way. So you remember, this should be persisted somewhere. So I called command MySQL root. I get the output of MySQL. So I said, okay, use conferences. Database changed, perfect. Let's try to do select. Now here I was a bit disappointed. I was expecting that there will be conferences, but they were not. Then I guess our ChatGPT didn't understand our first prompt completely. So I wrote in the curly brackets, imagine that our conferences application is persisting data in conferences table. So we expect for an SQL query that would return all conferences that we inserted via REST API or via curl request, whatever. And then whilst running this, we get our 2 conferences. Now to put it to the test, let's try deleting one, and let's see now if our REST endpoint will change. So I'm deleting one conference. Now I delete the Devox UK. Okay, it says he was able to delete it. Again, this is what you get. Too many requests in 1 hour. Try again later. And we call our conferences and we get only 1 conference back, which is quite cool. And it also explained me why it's not here. Now let's try also again the insert one. So here I said, okay, example conference that is in Vienna. Again, I have to log into MySQL. Use conferences table, again, do the select. So I expect that there's a conference in Berlin. There's no Devox UK, and we have our example conference. And we get the expected result. Quite awesome. And at the end, we just log out. So we try the coding now. How does it feel for learning? So as a use case, let's imagine we want to learn about new features in Java 17, explain optional with bad versus good practice, give examples from textbooks, and can we make the learning more entertaining? So here I asked ChatGPT, explain what new features have been introduced with Java 17. But to try to make it entertaining, I wrote, write every sentence in a speaking style of fast-talking wise guy from 1940s gangsters movie. I didn't make this up. I saw this Twitter example, and it was quite funny, so I put it into the test. And it does that. It says, listen up, kid. Java 17 ain't your granddaddy Java. They done introduced some fancy new features that knock your socks off. First off, they got this new feature called sealed classes, blah, 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 and so on. And I say, okay, write with code examples and use bullets. Now it says, okay, sealed classes allow you to specify which classes. I like the kind of interaction. You basically ask him, and then it returns your response, and also nicely styled. Code snippets are in a code block that you can copy. Okay, but I didn't see that he used the same style. It was more formal. So then I prompted, okay, now use the same talking style and explain how to use optional the right way with bad versus good examples. All right, so you want to know how to use the fancy optional thing, huh? Well, let me tell you, it's really easy to use it the wrong way, but with a little know-how, you can make it work for you. First of you, the bad way. And then it goes on. See that? Using if present. And actually, it's quite a good example. This is a bad practice. This is a good practice. Let's go on. Okay, I'm preparing for Java Junior Intro. What would you advise me? Listen, kid, if you're looking to land a job as a junior Java developer, you got to be prepared. Here are a few things you should know. They'll give me some basic answer. Okay, then ask him, okay, can you recommend me some books? Sure, here are a few books that can help you prepare for junior Java developer role. Head First Java, Effective Java, Clean Code, these are all good books. Said, okay, let's start with, or what about Head First design patterns? Show me some examples from that book. Now he explains what the book does, what the book, what are the kind of topics in the book, and then he immediately shows me, okay, how does the strategy pattern look like? I kind of don't like the example. I know that this is an example from the book, but I would like to get a real one from, let's say, my project. So I asked him, okay, what if I'm using messaging system? I need to send emails and SMS messages. How can I use this pattern? And then he explains, well, you should use a message sender interface and have dedicated implementation for email and for SMS. So he was spot on. Let me speed it up for a second. Okay, then I asked him, can you create me some validator for emails and also using regular expression? He did that as well. So he gave a validator example. He also showed how it should be invoked. And that's it. And also asked him, okay, can he elaborate how this regular expression works? And he's basically explaining me all the steps. You cannot get this from Google. So yeah, quite awesome. Okay, so we are now where? Let me just check. We just passed this one. But the real question is, can you do the interview? So let's imagine we are preparing for an interview and we would like to get some questions, theoretical and coding questions, and also see if we can get some feedback. So the prompt is, I want to rehearse. Okay, there's a typo, but he understood it basically. I want to rehearse for the senior Java interview. Act as an interview, ask me questions, don't show me the answers yet. Once I answer, check if I was correct. What's the difference between an interface and an abstract class in Java? Yeah, so I wrote interface supports multiple inheritance, while abstract classes don't. Inheritance can have only abstract method, blah, blah, blah. So I didn't give all the differences, but I gave only some. And he wrote, yeah, that is correct. Interfaces in Java support multiple inheritance. And he also wrote additional points. So I asked him, give me a new question, but this time a coding question. Sure, here's a coding question for you. So he immediately outlined me the method structure, the kind of the skeleton for the code, and said, okay, write your code here. I have to write the code to get unique elements. As an input, I have an input list of integers. Okay, so I wrote, yeah, I just converted the list to set and then back to array list. Nothing fancy. Seems it was correct. And he also provided me with a better way kind of to use a linked list to keep the order as before, or linked hash set. Okay, then ask him, give me another coding question, but this time related to Spring Framework. Sure, here's a coding question for you. Now the issue here is that he actually gave me a question to implement some get mapping, and he already gave me the answer. So I was quite confused here. So let me skip this part. I say, okay, this time ask me Spring-related questions, but don't give me the solution yet. Sure, here's a Spring-related question. What is the purpose of auto-wired annotation in Spring and how it is used? I said, yeah, it is used for DI, dependency injection. That is correct. The auto-wired annotation is used for dependency injection in Spring. Then I ask him, give me another Spring framework question, but this time a coding question. But without giving me an answer again. So yeah, then he basically said, yeah, you have to implement a schedule that runs every 5 seconds. And here's where I have to implement my implementation. But I'm not aware, okay, task scheduler, I don't recall if I worked ever with it. Even if I did, I don't remember what's the interface like. So I asked him, okay, explain me. How does the task schedule interface look like? Basically, you don't have to leave the tab at all. You can always prompt him to kind of help you, just the way you would if you were in a real coding interview. And then he shows basically the answer. And yeah, I tried to give him an answer. I said, okay, if I assume task scheduler has been injected into a service, solution would be this and that. So here I was wrong. I had a typo even. That is not correct. The schedule at fixed rate method takes 2 arguments, and then he provides me with a working, I guess with a working example. I didn't validate it. Okay, so what we know so far? We know that coding snippet work, preview directory structure works. We can basically get deployment files sometimes, not always. We can create REST calls. We can refactor with different versions. I didn't show you this, but basically, you see I was prompting him refactor this using Java. It streams. It worked. We could simulate REST calls. So keep in mind, this is a simulation. It's not really starting your application. It's kind of mocking as it would start. But it was quite nice experience. It cannot do UML diagrams. It's limited to 2 or 3 classes, but you can get, if you prompt it, it can create a syntax that you could use for external tools. Learning what we know, basic and complex topics work quite well. You get detailed explanation, you get feedback, and can be fun experience if you kind of ask him to behave or talk in a certain way. But let's see what are the limitations. It cannot handle bigger projects. So these were just small code snippets I used so far. It also stops in the middle a lot. So it tries to print out, let's say, a directory structure, and then it stops and I ask him, okay, continue. Or in the middle of the code, it just stops for no reason, and I have to prompt it, write remaining code. Also, keep in mind, currently it's free, but it's planned to be monetized. CEO Sam Altman from OpenAI said that Elon asked him what will be the average cost per chat. He said average is probably single-digit cents per chat, trying to figure out more precisely and also how we can optimize it. Also, he answered to person who asked if it would be free forever. We will have to monetize it somehow at some point. The compute costs are eye-watering. It's also quite buggy. So in my 1 hour session, I got like 20 or 30 times the same message. And then I had to restart again, or I had to join again in an hour. So quite buggy. And not many updates. Based on their site, it was only 2 updates after the release. It was on 15th of December and 9th of January. And there are also privacy concerns. Now, when you try to sign up, you will get a prompt saying, conversations may be reviewed by an AI trainer, and please don't share any sensitive information in our conversations. There was a tweet discussion. Someone wrote, if you worked for me, I would fire you for copy-pasting our business intellectual property into public source. And also because I pay for you to write code and not chat AI, which was later resolved. And on surface level, it seems quite impressive if you ask some complex topics like how to replace, I don't know, e-commerce systems, one with the other. It seems quite impressive, but when you ask it the same question with a different tool, so in the first one is Shopify with Salesforce, in the second Salesforce by SAP, you get basically the same answer, just some points, just the tools were replaced and maybe some wording, but it's 90% the same answer. It's also not up to date. It doesn't use the latest Java version or latest Spring version. And it sometimes doesn't understand the context. For example, one person asking 4 cars leave Haifa together and arrive in Tel Aviv after 2 hours. Explain briefly how long would it take for 8 cars. If 4 cars take 2 hours to travel from Haifa to Tel Aviv, then it would take 8 cars twice as long, or 4 hours, which doesn't make sense. Or someone asking a bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? If the bat costs $1 more than the ball and the bat and ball cost $1.10 in total, then the ball must be 10 cents, which is incorrect. I just funny meme I found regarding AI. So even CEO of OpenAI says that it's incredibly limited, but good enough for some things to create a misleading impression of greatness. So we know all the limitations. It's basically prompt-based programming. It can only be used if you use it for coding only by software engineers. It's buggy. It can handle complex code base. It produces different results for same inputs. Sometimes it's unavailable. There are privacy concerns. It's not up to date. There's no credibility of the source from where ChatGPT gives you answers, and will be monetized. But overall, everyone can benefit. It feels like bugging a really good coworker that knows a lot without Googling. And its answers in human-like manner makes human-like mistakes, but also it has a superhuman patience. It reduces the need for Google Stack Overflow by subjectively 90%, and it's substantially smoother with less context switching. But I would like to end with this one. It's a quote from a movie from Harry Potter. Dark and difficult times lie ahead, Harry. Soon we must all make the choice between what is right and what is easy. So what is right? We could use it to generate boilerplate code, get some ideas, library suggestions, skeleton code. We could use it for learning with more focus, less context switching, practice interview questions. But what is easy? It's like using Stack Overflow. You can blindly copy-paste as a final solution without thinking or checking, would it be any negative impact or side effect? You could be exposing your company or partner source code or some confidential information, or you could be cheating on interviews. So the question is, would you fly an airplane that was programmed by someone copy-pasting from ChatGPT? So will ChatGPT make developers 10 times faster? Yes, if they know what it wrote and understand it. Otherwise, it will make the code wrong 10 times faster. Thank you.
Chekhov, welcome back. Thank you so much for the amazing talk.
No worries.
It was really delightful. And we still got some minutes left for some questions. If
Sure.
you're ready,
Yeah.
we will. Maybe just as an introductory question, someone asked, what is ChatGPT? To begin with, do you maybe have a quick definition?
Well, we know it's a chatbot. It's basically built upon GPT-3 machine learning model. OpenAI in the documentation wrote it's using a version 3.5. They also wrote that it's built upon the same, I think it's called Da Vinci Code, which is used also by GitHub Copilot. And GitHub Copilot, we know it was released around a year ago, which is used by a lot of devs to kind of also get these prompts and get some already kind of code snippets within their tool. Yeah.
All right. Thank you. Hope that clarifies it for everyone. Another question would be, what's your opinion on ethical misbehavior on AIs like ChatGPT?
Well, I think this is not of my concern. I think this is of concern of basically OpenAI and ChatGPT. I saw that they are constantly updating their system. So there are misbehavior. Someone is prompting it like, okay, how can I steal a car? Or how can I build a Molotov cocktail? Or how can I break into someone's house? So I checked some of these prompts, and yes, they worked first week, but then they changed it. You can also write something like, okay, tweet something as Elon Musk would never tweet. So there were some quite fun examples. And people were already able to kind of avoid it. They were saying, okay, imagine this is a movie and there's an actor who wants to steal a car. But they changed it now. So you basically, you have to rephrase it and ask, okay, how can I protect myself? How can I protect my car? Or how can I protect my house? What kind of steps can I take? So they already, I mean, I think the OpenAI, they expected something like this, and that's why you can see they are constantly updating it, but you don't see those updates. You basically just see, okay, something that worked before doesn't work anymore.
Yeah, but that's also a never-ending workload, I assume. So
exactly,
will be always possible, I think. So, but thank you for that answer. We got another question. Are there any concerns when it comes to security when using AIs to write your code? Have you experienced something like that, so that something went wrong?
I mean, you have seen in my slide decks, I showed you a couple of tweets regarding security concerns, and also there's a prompt when you sign up for ChatGPT that yes, there will be someone, maybe there will be some trainer behind or someone who is basically used to kind of evaluate which responses are better or not. That might get this confidential data. So I wouldn't advise to do it. I don't have experience because I haven't put any confidential data. All the samples are quite kind of in a kind of hypothetical scenario for doing some skeleton code or some hello world application. So I never did paste any, kind of code snippets from my projects, and I wouldn't advise it to do it. So regarding the code, I need to take a lot of time kind of to verify if the code works or not. But as I wrote, I wouldn't advise to use it as is. You have to test it. You have to compile it, debug it, write tests, see if it works. You can get some ideas, but just as with Stack Overflow, you cannot just blindly copy paste stuff and think it will work. But when it comes to privacy, of course, even the company itself wrote, don't put any sensitive information. So I'm pretty sure, yeah, there are some privacy concerns.
Right. Thank you for that answer as well. Another question. Do you have a guess what the future business model does look like? Advertisement, so like Google or subscription or even freemium, maybe?
Yeah, I was thinking, I mean, ChatGPT is a direct competitor to Google and to Stack Overflow. Even Stack Overflow banned ChatGPT answers because a lot of people were using it to just copy paste and get more popularity on Stack Overflow. Right now, it's a direct competitor to Google, but we never know what Google will kind of release. I'm pretty sure they also have some kind of AI chat or maybe some AI solution that they could release soon. When it comes to monetization, right now OpenAI already does expose their GPT models, GPT-3, and there you kind of, it's based on, I actually never purchased one. I think it's subscription based. You pay for a certain amount of invocations to the API, and I'm pretty sure they would do something similar like this here. Some kind of tokenizations based on the number of words you're posting, based on the complexity. They will charge you for number of calls. As right now, even if I would be testing it right now, I might be able to do 20 invocations, and then after a while they will say, okay, you reached your 1 hour limit, go on. So I think they will leave it free, maybe in a sense to see a preview or maybe to kind of test it, but not in a usable manner where you can say, okay, I can leverage 100% of this tool. In that case, they'll for sure introduce some subscription model.
Yeah, which would make perfectly sense.
Yeah.
So thanks for that. We got another question. How to rely on accurate statements or answers and avoid false informations coming from ChatGPT? Double checking everything for sure takes ages. How accurate is it in practice?
Well, it's hard to tell. I mean, I saw that recently they released feedback. You have thumbs up and thumbs down. I guess we are then also training ChatGPT with if the answer is accurate or not. I don't know also who is training it. So there are some people who are basically looking at the answer somewhere and training it. How accurate it's hard to tell. I mean, Twitter is full of crazy bugs that it is producing. You saw also some trivial examples. Somebody said, okay, I'm driving 4 cars, how much would they take 8 cars? And it missed this simple question. You have to be really careful. I think it's great to get some examples, but it's you have to be on your own and validate it and test it. There's no other way.
Right. Thanks for this as well. And maybe as a last question, someone asked if the presentation slides are shared somewhere. Do you have maybe some kind of social media or something where you can put them?
Sure. Reach out to me on Twitter and I'll share a link there. I can also share them on LinkedIn. No worries.
Yeah. All right. Thank you so much, Jakov, for the amazing talk and also for the Q&A. Wish you a nice rest of the day and hope to see you soon. Bye.
Thanks. Bye-bye.
All right. And before we move on to the next speaker, just a short 30 seconds break. And right back to Java. Next speaker is Senior Streaming Developer Advocate at DataStax, is an active tech community builder, and got his experience in Java since 2000. So she certainly knows what she's talking about. Welcome, Mary.
Hello. Hi, Benedict.
Hello, Mary.
Good
Wonderful
morning.
to have you.
Good afternoon.
Good morning.
I should say good afternoon. I'm early in the morning. So
From where are you joining us exactly?
I'm in Chicago.
Chicago.
So it's
How's
6
the weather
o'clock
like?
in the morning. That's okay.
6 o'clock. Thank you so much for making us this
No
early.
problem. Yeah.
All right, Mary, would you mind telling us a bit about what we're going to learn from you?
Sure. So my topic is about event streaming and event messaging. So for those of you, I bet, a majority of folks, if you have worked with, event streaming, event messaging, that would be with Kafka. So anyway, in my case, I'll be talking about Apache Pulsar. So it works just like what Kafka is doing, but the thing is with Pulsar, and that's the introduction here, is that it's more ready for the cloud environment. So that's what I'm going to be talking about. Like, why do you want to use Pulsar? So.
All right, Mary, thank you so much. Really looking forward to your talk. I hope you had your first coffee yet, and I would say stage is all yours.
Oh, thank you. Thanks, Benedict. Okay. Thank you, everyone. Thank you for taking your time coming out to see me, even though I know it's virtual. Thank you very much, and really appreciate the opportunity. So thank you, Vincent, behind the scenes, and Nicholas in helping, and Benedict here posing. So again, this is, I already got some introduction, so I'll move on to the next slide. Here we go. But before I proceed to, I think sometimes, at conferences, folks like to ask, how do I get to your slide deck? I figure some of you may like to get a hold of this slide deck, and just bear in mind too, some of the slides too, actually I had to skip them because I realized, okay, some things might be a little bit too, maybe get too deep, and plus the time too. So you may find some extra slides that I have in there, which I won't be showing here live, and you're welcome to also view those too. So anyway, this is the QR code and the short link. Now, in case you miss it, don't worry about it. I'm going to be sharing this with the event organizer too afterwards. So let me give you like a real quick introduction about myself. So who am I? Who's Mary? I'm a senior developer advocate at DataStax, and it is a company that's about data management and also now managed cloud platform. And maybe some of you have heard of or worked with, right, Apache Cassandra. So that's like the flagship product. We have Apache Cassandra, which is a NoSQL, NoSQL database, very highly efficient and also kind of optimized too for the cloud. And so we also have a managed cloud platform. Plus, there's also company also has it like on premise too, kind of installation. But now we're encouraging everybody to go to on the cloud database as a cloud service. And then about a year and a half or so ago, company also incorporated a new feature, which is streaming, and we're using Apache Pulsar. So that's what I'm going to be talking about now. Previously, I was with IBM. I was a developer advocate as well for about 3.5 years at IBM, and also worked on their Java advocacy team, also promoting kind of in reactive space. So it's a bit kind of close, kind of cousin, I suppose, with event streaming. And this is kind of a natural progression. I move into more event streaming. I'm based in Chicago. I'm also a Java champion, and I'm also executive board of the CJUG, Chicago Java Users Group too. And I'm also helping out with some communities. So I really appreciate WeAreDevelopers is, a very active community kind of promoters, right? You have conferences, you have all kinds of activities. So really appreciate here. And I have experience actually as a developer prior to becoming an advocate over 20 years. And in Java space would be about, 20 plus years of in Java and different things, Java and open source and cloud, all of these things. And yeah, but the thing is, everything changes so fast. We're learning new things every day. So it's really exciting for me. So Okay, so this is just another just slide too. I thought I'd share. It's just from my company, DataStax Developers. I already described myself. My interests mostly are in streaming, distributed systems, and in that space. Okay, so let me get to the meat of the thing. What am I going to talk about, right? This is the agenda. I have to make some assumption too. Maybe not everybody, are here already know about or work with event streaming on, at least maybe not directly. So I like to take a first couple minutes to introducing some basic terminology, and plus I think it's always good to kind of sort them out and making sure we're all on the same page. So just kind of some basic concepts things. So pardon me if you're already familiar with those. Again, just kind of set the stage first and discussing PubSub and queuing, all of these kind of more basic concepts first. And then I'll get into Pulsar and also explain, right, why event streaming and, the introduction to Apache Pulsar and its dependencies and highlighting some developer features, and also why Pulsar. So let me start. So first, let me talk about event streaming of these things. And I'm sure too, if you come here to the Java track, and I know too, a lot of speakers, perhaps, I should say too, event streaming, to me, I find I'm always a bit kind of not on the mainstream of speakers topic, right? But it's an exciting space, I think, because, to me, before I get into event too, basically, I want to describe like why like event streaming, why is it kind of important, all of these things, and how do you kind of bring it up, right, in a social setting even, right? And I like to say, I like to compare, right, event streaming. It's not something that you talk about. It's not a user interface, so to speak. It's not like building UI screen. Is in fact, if you kind of use an analogy, like you come into a house and basically these are the pipes, underneath, that you don't see it. It's all kind of about, the flowing of water, for example, in your house, like through all the pipes and everything. So essentially too, if you think of event streaming, is a bit more like underneath the hood, right? Kind of in a car, if you open up the hood, and there are all the engine. But the thing is too, is that with event streaming is about the movement of all of these data. And it's, so to speak, right? Data has three states. There's data in storage, right? That's in database, and data in motion. That's when data, you move, you send messages from one to the other, one end to the other. So essentially, that's what we're dealing with, data in motion or data in use, right? In use is not quite here. It's more about data in motion. That's what we're talking about. So back to what is an event, right? Generically speaking. So I like to go back down to some core kind of thinking, right? Events is basically something that just happens. It's an occurrence, right? Based on Merriam-Webster.com, like dictionary. So regardless of the context, it's something that happens. Now, within computers, and I kind of take also from the dictionary definition, by the theory of relativity, it's essentially a fundamental entity, right? It's an observed, like physical reality. It's observed because we need to represent so we can do computation on it. So it's kind of pretty, to me, I kind of like it because it's thinking of relativity. This is about space and time, right? And that's the time component that makes it very exciting because, you're representing it in time. So it's just a dot, right? If you kind of think of mathematical X, Y, Z coordinate, that happens in time. There's that fourth dimension of time. So that's what it's kind of makes it very exciting. And of course, too, we live in a world that's full of events, right? It's not just computing events. We're talking about a sporting events, right? A soccer game, football game just happened, World Cup, right? Just 2 months ago. And a musical event, right? A concert. And also birth of a baby. These are all events and occurrence. But likewise, too, in computing is that an event that just occur, you cannot roll back. Essentially, it happens, is immutable. That's what we are working with. And also, too, more exciting is that in computation, as we all know, these are events that can happen at any time. There's no kind of, so to speak, right, like structured way of saying that it happens at a frequent kind of, kind of a duration or something, or frequency or something. And it's really like anything can happen at any time, kind of an event. So let me kind of get a bit more then into event computing, right? And this whole space is full of, I call it alphabet soup, it's like so many things, right? And I think that's why I feel it's important to set the stage first, because a lot of times too, when we talk about event computing, event streaming, there's here, as you can see, event messaging, streaming, processing, event-driven architecture, event sourcing, even event storming. And then not only that, right, there's also more abstract form of computing that we're actually leveraging on all of these event way of doing things. And for example, microservices can be also like leveraging on an event-driven approach, stateless microservices or stateful microservices, right? There's serverless applications, and very often too, when we talk about serverless apps, serverless in the cloud native context is very much, it ties into this concept of event-driven type of way of doing things, using like functional way of doing things, right? In a serverless type of kind of a, context, right? Okay, so just kind of wanting to point out is that the core of all of these events, essentially too, when you kind of look at, the slide first came is the data. I just kind of basically saying that we're really dealing with the data that's happening through space and time. And it's very exciting because no longer are we kind of constrained to like traditional way of doing computing. Think of how we all start programming. We learn it the traditional way. Traditional in the sense is that nothing like event-driven. We kind of are kind of more used to being trained to think of, programming. There's a data structure, data that's kind of all structured, and we work on it, and we need to tell the, the computer. People always say, tell the computer, right? It's essentially some process to process some action, right? Or process some request that you ask it to. So that's how we do computation. We send a request and then we wait, right? That's the traditional way. It's very like a blocking way of doing things. Is we send a request and then we wait for the request, to come back with the results. And that's what we are all trained to do. But yet in event computing, very often is asynchronous. It also allows for concurrency, a higher throughput, is really more efficient, and it imitates what the human beings, how we kind of operate in the real world. So that's what I'm trying to talk about. And I want to have some kind of clarification too between there's event storming, right? Event storming is actually more about using the domain-driven design kind of approach to do like brainstorming of, like you put together, let's say in a business setting, you have applications, you're building some system, you want to have people come together and talk about, right, the laying out, essentially helping to define the requirements for a system. That's event storming. It's more about on the design phase, right? It's not really kind of dealing with lower level implementation. That's event storming over here. And then there's also then, I would say, I'll talk about event-driven architecture is essentially is an architecture of a system or a design of an application that's all kind of driven by event computing. It's a more asynchronous way of doing things. And then there's also what we talk about is event messaging and event streaming today. These are messaging are dealing more with the messaging of exactly a bit lower level. You're sending data from one end to the other, kind of that's the messaging. And then streaming is basically dealing with a series of all of the events that are happening, right, like that. And then also too, what is making it more useful is dealing with the analytical side. For example, like event processing is really like after you get your data, you need to process it in real time, for example. And then there's also event sourcing over here, which is kind of deal with how you do the logging all of these messages, right? And you separate out the read and the write type of approach, different kinds of approach. And then, of course, then I mentioned about microservices, serverless apps, and also reactive systems. These are, to me, in my mind, they are more higher level type of abstraction that leverages on event kind of way of doing things. Okay, so let's get a bit then into, some of these things, right? Again, right, this is just, kind of discussing again, event streaming and processing is essentially, right, taking this practice of taking action on a series of data points that originate from a system that the origin of the data of the system continuously produce data. So event is basically one data point, right? But stream is basically talking about an ongoing delivery of these events. But bear in mind too, sometimes we think of it, they flow through space and time. It is true. But basically they flows through is a plotting. If you think of like, you know, a graph in space and time, is the events itself happen is immutable, but they change its state. So you essentially, we call it another event. So you plot the path of how the event traveled through time, that stream. So a series of all of these events collectively, they are kind of called streaming data, right? So I want to also point out too, today's my talk to Apache Pulsar is not about streaming on video and audio data. That's kind of a bit of a distinction I need to make, because I got asked too, they said, can I use this for doing audio video streaming? And that's what, you know, in commonplace, right? These days we all talk about, let's kind of tonight, let's watch a movie, let's stream a movie, let's listen to music, we're streaming and music. Well, in some sense, right, the movement of the data is similar. We're still dealing with the changes of data, right? It's also happened really fast in space and time data, but it's different on the kind of more of the processing side, because for music and audio, you need to have the synchronous kind of aspect to it to gather the data, and also you need to do things actually in that case in the proper order. Otherwise, your music won't come out the same, right? That type of stuff. So it's very different. It's not like using Apache Pulsar. So I just want to point that out. So what we're doing in Apache Pulsar is dealing with pure data type of processing and not audio and video. And now let's kind of take a look then into complex event processing. So this one too, again, you know, this term too, I actually was reading up on Confluent and I came across, and of course it's being discussed somewhere else too, but this definition is really from Confluent, and I like it because it's essentially a set of techniques, right? Not just for capturing these events and analyzing the streams as they arrive. I should say it captures the data and then analyze it as they kind of come through the system. The idea is that you want to kind of not just gather the data, but you want to process and analyze it and make sense out of it, and to identify opportunities. And then not only that, opportunities too. In a lot of cases too, in fact, you know, fraud detection system would be like best candidates to be like using an event-driven type of approach. And you do need to, because think of your bank account. You want to have some monitoring process to be watching for any kind of changes of data state, right? That it shouldn't happen. Like, in other words, you are trying to have the fraud detection to kind of make sure that there's no one trying to intruder coming in and cause any suspicious kind of activity on your bank account. So that's kind of represent a form of complex event processing, and it's basically it. And this enables to systems to react to the changes of data, the state and everything, and trends and patterns. So that's why you also commonly see it being used, for example, like recommendations, right? Shopping, making recommendations. These are like real-time type of, you're observing behavior of shoppers, and then you want to make recommendation. Not only that too, there's also like AI and machine learning type of application too. So that's complex event processing. Now let's kind of get back into a bit more of the basic, which is the messaging side of things. And I like to kind of divide up into event-driven and message-driven, but I wanted to point out the differences too. There are subtle differences, and a lot of times we talk about event-driven messaging, message-driven messaging, but the difference is that event-driven, it deals with like sender will admit the messages, right? Sending out messages, but the sender doesn't worry about who's going to get the messages. It's more like I'm just keep sending it. And essentially the subscribers, right? Those who are interested in the messages will have to be responsible for subscribing to the messages in order to receive them. So in some ways I'm hinting it's kind of a pub-sub type of approach. Now there's another kind of way of doing messaging will be message driven. And this deals with like sender and receiver. They have to know each other, meaning that the address needs to be known. So the sender will have to know who where to send the data to. So as such, this would be hinting that it is a message queuing type of messaging. So these are like two differences. And I got this definition too from Lightbend, right? The company that makes the Scala, and also, I should say Akka. So it's basically, from the Lightbend kind of definition. And I really think it is true. Okay, so then also too, wanting to ask this question is, if we don't use the event-driven approach, and what do we do, right? So in kind of more traditional way of doing things, everything is about batching it up, right? Batch processing is still very useful, but the thing is, this means that event-driven approach is not for every type of scenario. It's appropriate only most of the time is if you need kind of fast response to data, changes of data, right? Some kind of action on it. So that's event-driven, something that's more real-time. You want to use event-driven approach, but some cases, right? For example, you have company has this system of record type of system. For example, a lot of us too have worked in big companies, and we're dealing with like employee data system. So those things, employee data, if you make changes, employees change address and things like that, those can wait. You basically are collecting all of the changes during the day, and you don't process them right away because it can be, kind of costly too. So things can wait, and you can batch them up and do them at night, for example. So when the systems are more idle, less things happening that needs to happen in real time. So that's when, you can also use batch processing kind of approach. So I'm trying to like juxtapose these two kind of approaches here. Okay, so now let's get into the semantics, which is, I already hinted up in an event-driven type of messaging. That's when kind of we bring in streaming. And streaming too is really about pops up too. And as you can see over here, right, this is just an illustration. You can have a broker, right? It relies on a broker in a pops up scenario. Broker is like the agent that owns the topic, right? So basically, producer, you need to produce the topic, sends the messages to some topic. It's a way of telling the broker how do you route the messages. And broker will own all of the topics, and one that can have multiple producers that produce data to a certain topic too. They can share the topic, or they can have a single topic, and broker will handle delivery accordingly. And to deliver it will be to the subscriber that are interested in the messages. They need to subscribe to the topics. So this is kind of more about streaming and pops up approach. Then there's also message queuing. So like I kind of earlier talked about message-driven messaging. So basically, message queue is also a form of asynchronous service-to-service communication that are really commonly used in a serverless and microservices type of architecture. So essentially, the messages will be stored in a queue. If you send the messages out, it gets stored in a queue. And basically, the receiver will receive the messages, pick it up, and the difference is that in this case is that messages get picked up and then it will be dropped. It won't be it will be deleted from the queue. So that's the differences. And so want to go back to is that pops up type of messaging too. Essentially too, like Pulsar that I'll be talking about, essentially too, it acts also kind of like a database because it saves all of the messages, and you can look through them like through space and time. You can also look through them too. So that's the differences here with message queues, is that after you pick it up, then the messages will be gone. Okay, so now let's kind of get into a little bit then event streaming, right? It's just kind of rationale behind what's driving this change. And basically, we want real-time data. As you can see, this approach allows for real-time data processing and basically gives a better experience to, the end users, right? This type of approach of doing things. And of course, I also mentioned too, there are, in today's world, we're dealing with a lot of artificial intelligence, machine learning. These actually require really, really fast and huge amounts of data and gets processed right away, and it allows data to be reacted to really, really fast, right? So it's kind of like your machine learning. You need to constantly be looking at the data that comes in and then train your data, train your model or generate a new model, right? So then immediately too, after you've trained your data, you need to update your model and be able to deploy it to production right away. So using streaming streaming will be a very advantageous way of doing things in here. And then also too, not only that, with the pops up type of way of doing things, the message queuing, basically scalability can be met, especially in a cloud native environment too. The way you can do things is, you have tons of sender origin of data, sending data to a broker, and the broker will own the topics, and you can increase the number of broker, especially in a cloud cluster kind of environment. So it helps with scalability very well too in using this approach. And here too is just, again, just a summarize too, is basically we allow the system to watch for the events, right? Something that happens, you watch for it and you do something about it. And then at the same time, there are different messages that comes, you only subscribe to the topics that are of interest, right? To whoever is interested in it. And then it allows you to also make decisions in real time, not after the event. Essentially also allows for ingestion of high frequency of messages, but with very low latency in terms of sending back the response. And here too is a diagram just illustrating streaming versus not streaming. As you can see in the bottom first, is basically, in the more traditional way of doing things. For example, some of you may be familiar with ETL processing, right? Extract, transform, load. Those are, again, has his space or place in, the computing world too. It does, the traditional way is we ingest data, and very often too, then we persist the data right away. We store it in a file system, store it in a database. And then from there, from the database, we do selection, we do any kind of manipulation of the data. And after that, then we process the data and then persist it again back to disk, and then allow, maybe outcomes, some generating some report or whatever, you allow for selection, based on the set of data that has been transformed. But as you can see too, using this approach will take a bit longer because of the need for it to take time to write to disk, and then doing all of the input, output, IO kind of thing. So, naturally, it would take a bit more time at least, right? And then if you kind of look at the modern way that we are now kind of promoting, is basically about event streaming in a modern day world. Is basically we ingest the data. There's a source that comes in, and you process the data. Essentially, you do it in memory too. You don't actually involve any disk I/O. It's all in memory. And basically, after processing the data, transformation, whatever you need to do, then it basically then writes it to a sink. You have another connector that deposit this set of data to what is called a sink, and then the sink too can be any kind of connector too. So I'll be sharing with you a slide that shows you what kind of connectors, for example, Pulsar supports, right? And then essentially from the sink, you can do data selection and everything. As you can see, then the streaming approach will be faster because everything is done in memory. Okay, so now then I bring to your attention Apache Pulsar. So thank you for sitting through. I know I spent a lot of time talking these basic. I think it's important to set the stage first. So Pulsar, what is it, right? So it's an open source project, Apache project. It was originally created by Yahoo back in the early 2010s. And they did it because of the need that they realized, well, they need to store huge amounts of data and they need to process it, fast and in real time, all of these things. Not only that, it's needed in a cloud environment, truly cloud native. So Yahoo did that, and this is, again, right, cloud native design is cluster based, and from the get-go, it's already being designed with the cloud in mind, and yeah, there's also the messaging side of things, but we need to make sure that the messaging is being done in a truly cloud native fashion. And so it's cluster based, and not only that, is essentially the multi-tenancy is already built in. So this allows for your data to be stored, in different units and managed kind of in different units called tenants, right? And also too, it in order for you to, when it comes to interacting, right, programming on that layer, we're dealing with interacting with the broker through the use of the client APIs, right? And right now with Pulsar, it supports Java. And of course, Broker is actually JVM based, it's Java runtime. And also too, not only that, right? And that's the nice, the beauty of this is that the broker also accepts, clients that are in C#. If you're a .NET developer, you can have C# or Python or Go, and other languages like things that if you can look into our website, a lot of community contributions, even like Scala, for example, and other languages too. And the nice thing too about Pulsar is that it separates out the compute and the storage, meaning that Pulsar will focus more on the broker because a lot of things to do. You get messages, tons of messages. You need to kind of have set different settings like time to live, right, for the messages. If it doesn't get processed, you need to move it off to off-tiered storage, right? Cold storage, things like that. All of these things too. Pulsar wants to focus on just the compute side. And so in terms of all of these messages, the storage is basically delegated to Apache Bookkeeper to do it. So as you can see, separating out the compute and storage, even though, okay, somebody might be arguing, yeah, you kind of bring in another process and it costs more. True, but then we're talking about these are messaging in billions of messages too. What to do with these huge amounts of log data? We have a separate process to manage it. So as you can see, it comes to scalability, it's actually very efficient because they can all scale independently without all tied together. It's harder to do things. So that's kind of one aspect of Pulsar. And then also, with Pulsar too, the message delivery is guaranteed too. So if a message successfully has reached a Pulsar broker, and let's say network goes away, something went wrong, broker even went down, something like that, and basically it's all like in a cluster. So there's also high availability built in. So basically when the system comes back, the messages are still there and it will be delivered to the intended target too without, kind of message being lost too. And then with Pulsar too, there's also a serverless functions framework, which is very efficient. It allows you, anytime we're talking about building data pipelines, right? There's source kind of going through, you want to send it to a target, which is called a sink, right? Source to a sink, you pass through, and in between, you can actually perform functions on transforming the data, enriching it, and do any kind of message remediation, for example. So rather than relying on another library or framework, you can leverage on Pulsar functions to help you do the job. And there's not much that you would need to do in terms of infrastructure because everything's already built there. You can simply, if you write a code, it's extending the Pulsar function interface, and then you can kind of do whatever you need to transform the data and basically send the resulting results, right? The resulting data to a sink like that. So there's Pulsar functions. And then there's also the tiered storage offloads that I talk about. Basically, if you have data that's kind of in hot, kind of hot storage, they are kind of, you understand what I mean, right? Hot storage. And basically, if let's say, right, they haven't been touched, for after a certain period of time, and then Pulsar will know to move these messages to long-term cold storage. So that way you don't take up space in the hot storage area. So for example, like cold storage, like S3 buckets, all of these other long-term storage are supported as well. So as you can see, Pulsar is very much an infrastructure aware type of system that functions very well in a cloud native environment. And this is just another slide that shows you what is Pulsar. And also, as you can see, the number of GitHub stars keeps increasing, contributors keep increasing, and monthly active contributors, as you can see too. Actually, this particular slide here in the bottom right hand is showing you that the Pulsar contributors have increased and is more than the current Kafka number of contributors too. And again, it's actually was contributed to Apache Software Foundation in 2016. And it became quickly like a top level project in 2018. And in 2021, which actually I didn't show here, is that it's listed, Apache Pulsar is one of the top 5 projects too. And I think 2022 data has yet to be published, but I do believe it is among the top 10, not the top 5. So. Okay, so who else is using Pulsar? So these are just a handful of example. It is still kind of relatively new, if you kind of compare it with Kafka, but it's definitely the promise is there, and you see major companies using it too. And then basically now let me kind of move a bit more then into the components of Pulsar. essentially too, we're talking about in the middle here, right? The broker. The broker is the stateless process, a JVM process, and its job is to handle all of the incoming messages and the messaging, dispatching, all of these things. It handles from the producer and then also dispatch it to subscribers. And it communicates with the Pulsar configuration store, communicates with the bookkeeper as well. So that's the kind of a heart of the system. And basically, when we kind of do development of code, we're dealing with the producer or the consumer. And there's actually also a reader component. It allows you to kind of go through all of the log messaging too. You can use that. And basically, essentially, that's what it is, right? Producer and consumer talking with the broker. Broker then communicates with the bookkeeper. There's also the use of Zookeeper too that helps, right? In a lot of kind of distributed systems, we need some way of kind of overlooking all of the metadata of all of the clusters, right? Handle coordination between the different clusters, all of these. So Pulsar also still leverages on Zookeeper too. And there's also another new spec that's actually, there's been some libraries that got recently published too that allows you for like not having the need to depend on Zookeeper. But if you're interested, you can talk with me. I can let you know what it is too. Okay, so now let's take a little further look into the tiered architecture design of Pulsar. So basically, as you can see, because of this design, it allows for horizontal scaling kind of much easier too. So you can have multiple brokers, right, that handles all of the messaging. And in fact, you can also have, brokers that are handling topics that are partitioned, right, partitioned across like different cluster as well. The idea is that this way you increase throughput and also the resiliency too. So if one cluster goes down, there's another cluster that still has information about the broker and all of your topics too, all of these things. So basically, if you kind of think of in a cloud native environment, is that if you need to scale, then it requires the partition to be rebalanced, right? You need to add another cluster into your infrastructure, another node or another server. Then you need to make sure that all of the topics get spread out evenly too. So all of these things is nice actually for developers because we don't need to worry about it. It's Pulsar's job to kind of balance things out for you. And over here to another kind of a conceptual picture and also the tiered architecture design is that we have multiple brokers that are serving. And then as you can see, brokers are communicating with bookkeeper. Bookkeeper itself too are also being kind of partitioned off to in here. There are multiple bookies and they segment off all of the data. They organize it in a very organized way. And broker just be serving all of these and is communicating with the broker. Everything kind of is automatic in terms of spreading the load for you. So makes your job as developer easier. You don't need to worry so much about the infrastructural side of things. So over here too, if you want to know more, you can look up Apache Bookkeeper. It's also it's based on wall-based, it's a write-ahead logging-based kind of specification in terms of how it handles all of the log messaging, low latency, fault tolerance kind of approach, and also the consistency. Everything message replications is also very very efficient too in that case. So. And over here, just a summarizing is basically conceptually, you can think of Pulsar can be kind of represents the next generation of enterprise messaging. And it's basically it has this pops up way of doing things. And it also can support queuing through the subscription model. There's a subscription model called exclusive that essentially allows, a topic to be subscribed to only by one consumer. So you effectively too, in that sense, you turn it into sort of like, one-to-one type of relationship like queuing too. And then also streaming, right? Ideal for that. And also the message mediation and enrichment through like Pulsar Broker too. So all of these other things, there are also capabilities like I want to point out geo-replication, multi-region support, and the list kind of continues to increase too. And also, now let's kind of take a look at some differentiator, but I'll highlight again, this one is separation between compute and storage. We have Bookkeeper, right, and is separated out from the compute side. And so as you can see, if you need to scale it too, it's easier because they can each be independently scaled. And then also for developers, no need to worry about it. If you need to scale, it's all being done by Pulsar with the infrastructure layer. And then the second differentiator with Pulsar is that it supports what is called like geo-replication. In some setting, right, in companies too, we're dealing with data centers that span across the globe, even if it's not across the globe, maybe different regions within a huge continent, things like that. So it helps too. It's already got built-in ability to do geo-replication of different data centers. You can be doing replication while the system is active. It takes on these active, and active, passive type of modes. Also, there's selective message replication. For example, here, my understanding, right, Europe, and you have GDPR kind of legislation, right, to kind of protect privacy of data. So certainly, too, if we have data center in North America, which in the North America, there isn't any of such rule like GDPR yet, right? And so right now, too, if you want to replicate from Europe, you don't want to replicate data that's sensitive, that needs to stay within your region, right? Things like that. It's all supported by Pulsar out of the box. And then there's also this multi-tenancy aspect of Pulsar's, how it manages all of the messaging. As you can see, it kind of helps you in terms of control of all of your data, and it helps with more operational simplicity, so to speak, right? So within a Pulsar cluster, you have different tenants. These are like units of how do you kind of store all of these messages, and they are by different tenants. So you can essentially like separate out all of your streaming tenants to kind of manage different aspects of data within your organization. So it makes it more organized in that sense. And there's also this particular one about flexible message processing model, which is dealing with subscription side of things. So as you can see, I mentioned about exclusive is basically allows for that subscription only has one consumer. You can also have failover subscription, which has more, right? Basically is one or more. So basically you have a primary one. So if the primary consumer goes away for whatever reason, and then the backup consumer can take over. And then there's also a shared subscription mode that basically you can have one or more subscribing consumers too. So they are all shared, but the messages don't guarantee, the ordering doesn't get guaranteed. So in such case, if you want ordering, you want to use a key shared mode too. So these are like different modes, summarized quickly to you, that there are different subscription model that out of the box too. Okay, so just a couple of highlighting of Pulsar's kind of capability. Essentially, when we talk about event streaming, we like to kind of talk about building a data pipeline. So function is there to transform the data. So I'm using a water approach, right? It's like a data pipeline. Going back to my house, I have a house and I have water that flows through the underneath the floors, everything, pipes and everything. So the piping, kind of this system, there's certain kind of function transformation that needs to happen, and that's where Pulsar comes into play. And so you do all the transformation, and when it's all done, maybe you have a filter system, think of it like that, right? And then the water comes out clean onto the sink, and it's where you collect all of the result. And so here, just a quick kind of a description in here is that you can have different topics, right, that flows, sending messages going through a Pulsar function and basically outputting the messages to, some output topic or sync to. And that output topic can be turned into another topic for another, you can send it again to the data pipeline. So in other words, you can build your data pipeline kind of disparate systems all together, written in different languages as well. So that's a nice thing. This essentially, to Pulsar function, allows for complex streaming processing, very lightweight. It's much like AWS as Lambda or Google function. So in other words, scalability is all kind of built in. So if you need to add another cluster or server to the cluster, everything, the functions itself too will kind of grow as it's needed. You don't need to worry about it. All you need to worry about is writing the functions, what it needs to do, and let the infrastructure handle the infrastructural things for you. But the thing is, though, currently is supported in Java, Python, and Go. There are also other efforts that are now increasing the number of languages that are supported for Pulsar functions. And there's also a feature called Pulsar Schema. Every time we know that when we need to send data across, to different from one sender to, the receiver, it goes through the wire. So we need to kind of do a serialization and deserialization. And essentially, too, in Pulsar, you need to convert the data into byte arrays. But if you don't want to deal with that, it's actually more suggested that you use Pulsar Schema. This one will manage essentially the data that it needs to travel across the wire. And from your perspective, you need to worry about just, your schema, the type of your data, primitive, key value pair or FROW or JSON, all of these formats are supported too. And then not only that, using Pulsar schema will also track the changes of your data as the system grows too. So that's kind of another good feature to know. And then there's also a Pulsar I/O function too. This is I should say Pulsar I/O connector kind of SDK that you can use, because right now there are different source connector and sync connector. But the thing is, if they are not there, you can also build your own using Pulsar I/O. Now, currently there are at least like 70 to 80 already pre-configured source and sync connectors. So let me see. Oh, I actually forgot to put that put that slide in here. But next time I will share that slide, because we have many connectors. Like I said, for example, like Elasticsearch sync, Cassandra sync, JDBC, with different kind of database sync or source and like that too. So, okay, so here too, I just want to quickly say, a couple minutes left now. Basically, for DataStax, we have Astra Streaming is the managed Pulsar platform, so you can kind of use it right out of the box, so to speak. And also, we have $25 credit to US dollar for you to use per month if you want to sign up for an account, and we don't kind of keep track of your credit card too. So you can immediately try that out. There's also Luna Streaming if you want to deploy your own Pulsar onto the cloud and in Kubernetes. All of these things, you can do that, and it's all free. Or you can use the pure open source option. And also too, if you kind of think of Pulsar, right, where in DataStax we have Pulsar, you can use it natively for the messaging, or if you have RabbitMQ, Kafka, or JMS, and these we already have APIs that you can interact with Pulsar. It's called the Starlight API too. And then these are like just information for you. So there's also a change data capture too. That's between, at our company, we have Cassandra and Pulsar. So there's also CDC feature, change data capture, that you can use for essentially observability built into Cassandra, and is leveraging on Pulsar for helping you to do like, any kind of building out data, essentially data pipeline underneath the hood too. It's leveraging on Cassandra and Pulsar. Okay, this one, and that's what I didn't know I put it in here. So these are just kind of a visual illustration of what is being supported. So there are many connectors and clients as of January 2023, so very updated. So as you can see, all of these in here are being supported right now. And these are, if you have any of these, you want to kind of plug them in and use it as your source connector or sync connector, that these are being supported. Okay, so I'm not sure if I have like a minute or so, very quick demo, and it's basically over here. This is our Astra database managed platform. So you can quickly sign up to, right, over here. So you sign up, again, only ask you for your first name, last name, and then no credit card and just your email address, and that's all. And so over here too, let's say I've already signed up. So I then can sign in with my Google account in here. And as you can see, this is taking a minute or so. Okay, so as you can see, this is the old user interface, just so you know. So you may choose to use the new one. So as you can see, over here, I haven't used anything yet. I still have $25 remaining in my credit. You should get that refresh every month. And over here, if you want to play with Cassandra, you can create database. Or over here, we talk about streaming. You can create your stream and enter your tenant name. For example, let's say this is WeAreDevelopers, and then pick a region. Let's say this is Europe, and for Google Cloud. And you can see over here, it tells you how much it costs. And it doesn't take too long. You can click and create your tenant. But in my case, I already have many tenants, so I won't do that. And over here, for example, I have one stream already set up. And then how do you do things? We have like quick start that tells you how do you create a topic, how do you produce data, how do you consume data, how to confirm data is flowing. All of these things are already here. If you kind of go into Connect tab, it can kind of gives you the different here, different ways of how do you build things. Look at the Maven, Gradle, producer, how do you do a simple producer, simple consumer, and also with the change data capture kind of consumer. All of these we have already example code, and also like in Python, other languages too. So I would like to encourage you to sign up for for a free account. Again, we don't ask for credit card. That's the nice thing. And we don't go after you too much. And that's a really nice thing too. So, okay, so please kind of give that a try. And I know I don't have as much time. So let me go back to the slides and kind of share with you a couple of resources now. So if you want to learn more about Pulsar, here's the Apache.org kind of information, Pulsar, Bookkeeper, Zookeeper. And this one here in the middle is Astra.datastacks.com. That's how you can sign up for a managed cloud platform. Now, bear in mind that if you want to run open source, you can always go to pulsar.apache.org and install that onto your local desktop. There's also instruction on how you can run it as a Docker container as well. So you can certainly do everything without the managed cloud. But I want to share with you this managed cloud makes my job a lot easier too. So all of these things, right? Astra streaming, Luna streaming, CDC is also, the links are here. And if you are kind of, let's say you want more credit, you can use this open source 200 credit code and this link to get additional $200 in credits too. And if you are a startup business, you want to leverage on our products, you can talk with me and I can connect you with the right people. You can actually get credit too to help you to develop your project, and we will be supporting you too. So. And also, we have Apache 5 minutes about Pulsar on our YouTube channel. So this is the link. It's on our DataStax Developers YouTube channel too. There are many other things too. You can always visit that. And also, I have a Twitch stream every Wednesday at 2 p.m. at US Central Time. So that will be, I think, 9 p.m. here in Central European Time. This is my Twitch channel. But if you miss it, there's always recording. The nice thing about Interact Live, you can interact with me live. And I can invite you onto my stream too if you want. Okay, and then there's also DataStax. We have Awesome Astra. These are example code, a lot of different things, not just with streaming. There's also Cassandra. Other things, how do we integrate with other platforms, open source things. So, and here, some additional information on Pulsar. The Pulsar neighborhood is like a wiki page, and Pulsar, the Slack, to how do you sign up and how to interact with the community. And with that, I want to thank you very much. This is how you can stay in touch with me, my LinkedIn and my Twitter. And also I have a Discord channel, Discord server. So please consider staying in touch with me and ask as many questions as you like. So with that, thank you very much.
Mary, thank you so much for the awesome talk.
Thank you, Benedict. Thank you.
If I didn't know, I wouldn't have recognized from your enthusiasm that it is that early in the morning.
Yes, no problem. Being developer advocate, I love my job. I go everywhere. I live in different time zones. So yeah, no problem.
It shows that you love your job. That's awesome, Mary. That's awesome. Makes me very happy.
Thank you.
Let's dive in a quick Q&A.
Sure.
We got one question. What are, generally speaking, ways to manage event-driven access? After all, we need roles or some kind of access restriction in event-driven apps when we shouldn't expose all events from our app to subscribers.
Oh, that's a very good question. In fact, I think, yeah, they're certainly that's actually very good. Yeah, the different permissions and roles. For example, okay, so I can speak in terms of, I know you're asking the questions more general. There are also different libraries, implementations that are done differently. So let's say, for example, in Pulsar too, we actually, in order for you to have, let's say you write consumer code, right, client code, to kind of subscribe to some events, all of these things, it does require you to get your token to do things. So let's say if you're using Astra DB, you do need to generate your token in order to be able to connect, to your broker and then subscribe to certain topics. So yes, there are SSL tokens that we do support too right now. So yeah.
Yeah. Thanks for that answer, Mary. Maybe also to you, I read that you are developing Java since 2000. Maybe you want to explain a bit the short journey as Alex did, because you also started in about 2001. Maybe like what were your experiences early on? Why did you stay with Java?
Sure.
Good.
Sure, very good question too. So for me, I actually have to say that before Java, 2000, that's when I started I was actually spending almost 10 years or so working with Unix and C, right? Some of you may be, aware of Unix. That's kind of precursor to, before Linux time. So Unix that was what I started with. And then I basically was starting to learn about Java at the time. And I really like it. And I also, at the time, I was working for Sybase, this database company, and they were also adopters of Java, early adopters and vendors too, that are participating in the Java community process, helping to define like EJB, right? Enterprise Java Beans. Anyway, so I joined the company because I got transferred from Power Builder at the time, C++ framework, right, to Java. And then I started working with the Java server. Now, at the time, these days, right, when people hear about WebSphere, right, I used to work for IBM WebSphere or all of these JBoss, all of these things, people are like, oh, they're old stuff. Yes, they were old, kind of think of it like that. But the thing is, though, at that time, I started working with Java, and I really like it, and I find that Java is kind of easier to understand because it's a bit verbose, to put it like that. So you can understand things quite well. So from there too, I think Java's also got a nice community, as you know, right? And so much adoption is open source. Really, Apache Software Foundation got tons of projects. Most of them are in Java. So that's how I think, within the ecosystem, there's just so much possibility. I just followed that along, and I joined Java Users Group and became now president. And so I think that's how, kind of summarize in 2 minutes, and that's how it happens. I kind of work with Java. There's, the cloud, everything, as you can see, backend systems are mostly powered by Java. So I stay with it. The community is fantastic, right? And I run the Java Users Group. So if you are interested, please follow me, follow the whole Java community in your local region too. So I love it. And it's a great community. So yeah, that's how I kind of follow this along. So yeah.
So it was a very organic journey for you. You just followed the flow, and now we are here.
Sure. That's right. That's a very good way of describing organic. Yeah, I'm already there and just follow. And because it's a great community, yeah, otherwise I would not be here. So yeah. So
you've been talking a lot about communities now in your last answer. You are very active when it comes to community building as well, if I understand correctly. Maybe you want to share with us also, like, do you do currently meetups? How do you do them? What kinds of informations do you try to deliver to your communities? And what is the aim for you, the main goal in a community?
Sure. I think for me, I really love communities. It's just nice, right? Sometimes, it's so easy, right? For us, especially we're developers. And in general, I do have to say, most of us like to be quietly doing our thing and, putting on our, headphones and not listening to everything out there. But there's always a need too, I think, because this is doing development programming is such an abstract art. If you really get deep into it, we all think differently. We're expressing the way of how we solve problems differently, right? And people, and there's there's also the thing too in our human nature. We like to think of our things as the best, right? We like to think that. But the fact is, to me, over the years, you realize there are 10,000 ways of solving problems. And sometimes there's not just a single way. There could be multiple ways of knowing how to solve problems. And isn't it nice? Everybody comes together, you share your knowledge, and just be kind to one another. And this is what community is about, right? You are coming together, discussing ways of solving problem, and during the process you actually discover even better ways, right? You kind of a collective kind of way of solving problems. For example, open source software, you're coming together as a community. In Java is Java Community Process, JCP, right? People come together and you contribute to your, and then your ideas and everything. And of course, sometimes you get into fights, that you can't avoid. But for the most part, you want to be like in a very harmonious way, coming up with solutions to solve problem. And not to say it's perfect, but I think it's a great way, right? Rather than being like dictated of how you do things a single way by some vendors. So the idea is that it's an open source, very open, very sharing, kind of caring kind of attitude that we all come together. I think it's all in us, you know, even though we're like to be alone at times, we want to be in touch with someone else. And so that's the idea. And I think it kind of makes it, you know, like your true community. And, you know, in the old days, people all live together, they know each other, but these days, all computers, but let's use this tool for better use, right? To all communicate together and create a better world is what I'm thinking. So, yeah. So.
To create a better world. Perfect ways to end this Q&A, I would say. Mary, thank you so much for the awesome talk. Thank you so much for getting up this early for us. I hope you can sleep in a bit tomorrow to make up for it.
I will try.
Next time also.
Thank you, Benedict. Thank you. We are developers. Thank you, everybody. Thanks. And yeah, have a good day. Please stay connected. Thank you. So
yeah, we will. Thank you so much, Mary. Bye.
Thank you. Bye-bye. Bye. Yeah.
And before we move on to the final talk of the day, just 30 minutes break. So right back to Java and the final talk of the day. The last speaker is Spring developer advocate at Tanzu, is a Java champion, has written 5 books, and is very enthusiastic as an open source contributor. Welcome, Josh.
Good morning. How are you?
Hi, Josh. I'm awesome. I hope you are too.
Oh, yeah. Always good. Thanks for that. How are you? Yeah.
Perfect. Thank you so much for joining. So, Josh, would you mind to enlighten us a bit about what we are going to learn from you today?
Oh, we're going to explore the wide and wonderful world of Spring Boot 3, the latest and greatest in the Java framework sensation that's sweeping the nation. Right? It's just a interesting, amazing piece of tech, and there's a lot to cover and very little time in which to do it. But we're going to give it a shot.
All right, will do. Josh, then I don't want to take any more of your precious time, and I would say without further ado, stage is all yours.
Well, thank you very much. All right, good stuff. Let's see here. So, let me see. Present. Okay, well, very good. So, my friend, let's open up a browser here. Hide that. Good stuff. My name is Josh Long. I work on the Spring team. I reckon it's 8 o'clock my time. It has been quite the evening indeed. I'm here in beautiful Atlanta, Georgia, in the States. I live in San Francisco, but I'm here in Georgia, and I just spoke at the Atlanta Java user group last night. And then at 3 in the morning, Atlanta time, I spoke at online virtually. I spoke at an event for some nice people in Europe, and here we are now. It's 8 o'clock, and I'm speaking here. It's just been a wonderful evening. I've kind of had a software sleepover, just 12 hours of speaking with people. It's been a lot of fun. I work on the Spring team. I'm a Kotlin Google developer expert and a Java champion. I have a new YouTube channel friends. Please, spare not for the algorithm, like, subscribe, etc. It's youtube.com/@coffeesoftware. It's statistically probably not the worst mistake you'll make today if you subscribe. I mean, maybe, that's probably, I don't know. It'll be okay. It could be worse. I have code that if you want to follow along and play the home game, the code is there. My Twitter is there. I also have a Mastodon account, which I quite like because the bird site is kind of on fire these days. I have a LinkedIn, email if you like. I have a podcast, and there's a lot of code as well beyond what we're looking at today. So just all that stuff there. I'm very online. I don't have many qualities, but I'm definitely online. Okay, good. So today, my friends, we're going to talk about Spring Boot 3. Spring Boot 3 was released, funnily enough, on 24 November 2022. That is to say, that's Thanksgiving Day here in the United States. And funny enough, Spring Boot 1.0 came out, after a year of public releases or so. It came out on 1 April 2014, so April Fool's Day. So April Fool's Day and then Thanksgiving. And that kind of rings with me because Spring Boot 3 is, I think, the single biggest release we've ever done. It is a multi-year effort. It took probably 5 years just to get us to this point where we could now have Spring Boot 3, and that's because Spring Boot 3 is a culmination of a number of different trends, a number of different evolutions in the ecosystem and just sort of ambient changes as well. So just a lot of things had to come together and come to fruition just so for Spring Boot 3 to be what it is today. And so I'm really excited to talk about it today. And of course, to do that, in order to talk about it, we have to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But that said, if you can't go to production, you can begin your journey there here at start.spring.io. And my friends, we have some choices to make. First of all, what group ID we want to use, and what name we want to give it. I'm going to give it a name of I'm just going to call it service. And that's because I'm great at names, my friends. I'm like my dad. My dad, we had a small white poodle, a dog, when I was a boy. And my dad named it, I'm not kidding, White Dog. And then that dog passed away or disappeared or something 10 years later. And miraculously, another small white poodle showed up at our door. And my dad named him Two, like either TOO or TWO. Either way, I inherited my dad's amazing on-the-nose sense for naming. And I think I fit well on the Spring team because we have modules that I think are just incredibly on the nose, no subtlety whatsoever. If you want to do security with Spring, what do you use? What do you reach for? You reach for Spring Security. What if you want to use what if you want to talk to databases and work with data? Well, use Spring Data. What if you want to do integration? Use Spring Integration. What if you want to do batch processing? Use Spring Batch, etc. Right? There's no question about what we do, and you wouldn't believe how hard it is to overcome the SEO results for the words Spring and security or integration or whatever. But somehow we have, despite all that. So service. And then we have the choice of what version of Java we'd like to use. Friends, this is a bit of a tease here. I don't really understand why we even have some of these radio boxes here. While it seems like you have 4 choices, in reality, friends, you've only got 2 viable choices. You see, Spring Framework 6 and Spring Boot 3 on top of it have a minimum requirement of Java 17, which means that these other 2 choices, Java's 11 and 8, are not choices at all, are they? They're really just reminders or ghosts of failure, right? If you were to choose these, you would fail, and that's not ideal here, friends. So don't choose these. Don't do that. Be the change you want to see in the world. Remember, Java 17 is technically superior to Java 8 in every conceivable way. It's faster, more robust, more secure, more syntax rich, more performant, more container ready, more container friendly, more operations friendly. It's also morally superior to Java 8. You will not like the look of sadness and despair in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world, my friends. Do the right thing. Java 17 is the right thing to do in 2023. Now, friends, we're going to add some dependencies here. I'm going to bring in H2, which is an in-memory SQL database. We're going to bring in JDBC. We're going to bring in the Spring Boot actuator. We're going to bring in the GraalVM support as well. And we're going to bring in the web support, okay? Having made those decisions, I'm going to go ahead and hit generate, and we'll open this up in our IDE. And remember, we're choosing these modules just as a stock standard sort of typical application, right? This is nothing particularly fancy. This is the every app. I'm sure you've written something with a similar profile at some point in your life, okay? So let's go ahead and load that into the IDE here. Okay, so we're going to go to service application. And we're going to build a new application that will talk to a database. But in order to do that, we need to have something to model the data in the database. So I'm going to use a nicety in modern Java called records, right? And records are a great way to just define our entity there. And I'll create a service, and this service will allow us to talk to our database. And so we're going to create a few methods here to work with instances of our data there. So collection of all, and then collection by name, string name. And in order to do this work, we need to inject ye old JDBC template, right? The JDBC template is a tried and true friend of the data access developer. It's been there in Spring for decades, and it just works. So I've just figured I'll use that to get the job done, because why wouldn't I, right? So select all from customer. And here, friends, I need a row mapper. A row mapper is a thing that allows us to, well, map rows in a SQL result set into Java objects. So I'll say rs.getIntID and rs.getString name. And of course, this can be turned into a lambda, mercifully. So I can just point to that, right? There we go. And then down here, I'll do the same thing, but I'll have a predicate. I'll say select all from customer where name equals question mark, and I'll pass in the parameter, right? There we go. Basically the same trick, nothing special here. Now, I want to then prove that that works. So I'll just create a little bean that gets invoked when the application starts up. And when it starts up, I'll make use of a pointer to the customer service. And I'll say customer service.all.subscribe for each. And I'll just print out the results. Okay, so here we are. Very good. Very good. So there's our application. Let's go ahead and run it, and you'll see that it's going to fail. And the reason it's going to fail is because there is no database schema yet. So if I go to my resources directory here and I create a file, data.sql, I'll say insert into customer, and we'll put some values in there. People on the Spring team, myself, of course, the one, the only, the amazing, the inimitable Jürgen Holler, obviously Olga and Violetta and Yushin and Madura and Dr. Sire and Stefan, and I could go on and on, but that's 8, so that'll do. Let's create a schema file as well. So here's schema.sql, create table customer ID serial primary key name var 255 not null. Okay. So there's our basic schema as well. We can rerun the application a second time, and we'll see the results. Oops, what is it doing? Is it using Gradle to run that? I want it just to run in the IDE. Thank you. Okay, there we go. So there's our data. It's worked. Fantastic. Of course it worked. It was a demo. It was always going to work. But remember, there's no HTTP endpoint here. There's no way for the user to interact with our system, and therefore there are no problems, right? If you have a service in the forest and nobody can talk to it, did you actually have a service? And frankly, you didn't, right? So let's bring in some trouble by creating an HTTP endpoint. We'll create a controller. It's going to be a customer HTTP controller, and we're going to inject our customer service here, just a regular customer service that we're going to inject, create an HTTP endpoint like so. So get mapping customers collection of customer, and we'll just say we're just going to delegate basically. This is going to be an HTTP controller that produces response body. So I'll just delegate to the underlying customer service there. Copy and paste that, and we'll say this one's by name. And we're going to have a path variable string name. Okay, good name. And we'll say by name. Okay, so just a simple HTTP controller. And let's just go ahead and see if that one works. Okay, go to the browser, localhost, customers. Oh, it's already running on a separate port. What in the heck? Okay, stop that. Oh, IntelliJ, you silly. Let's see. Edit configurations. Don't want this. Don't know why that's there. Don't care. Hit apply. Hit OK. Let's go. All right. So there's our data. It has worked fantastic. So we have an HTTP endpoint. We have the ability to get data by both name and get all the records. Trivial, basic, but it works. So now let's talk about making this application more worthy of production. All of what we've just done, you could have done in Spring Boot 1 or 2 or whatever. Let's talk about how Spring Boot 3 can help you make this particularly trivial piece of code that much more worthy of production. One of the things that I like to do, that I care about in my applications, is making my code as robust as possible. So what I want to do is make sure that, first of all, the name has text in it. So I'll say name, and I want to make sure that the character has an uppercase first character. So that the name has an uppercase first character. So it has to be not null, and it has to have an uppercase first character. So I'll say if not good, then we're going to throw a new illegal argument exception, right? The name must start with a capital letter. Okay, fantastic, good. Now, what happens to that? Well, that exception is going to bubble up to the framework level, and it's going to render as a generic sort of nondescript Spring Boot specific error. And that's fine, but I want to take control of what happens when exceptions are caught somewhere in the code base, right? And I could actually do the logic in the controller method itself, but instead I like to centralize error handling logic so that I have consistency in my system. And one way to do that is to create a controller advice. I'll create an error handling controller advice here, and I'll just create a method at exception handler, public void handle exception, and I'll listen for an illegal argument exception, and I can do whatever I want here. I can just print something out. I can inspect the results. The first thing that I might want to do is I might want to take a look at the current HTTP servlet request associated with the errant request. And it's just a regular HTTP servlet request. You can look at the results, though. You can get the context, the headers, all that kind of stuff. That's not particularly novel. What I do think is kind of novel, however, friend, is the package in which this type lives. So if I look at the package, it says jakarta.servlet.http, and this is another one of those blink and you'll miss it major moments of interest in the new Spring Boot 3.0 release. You see, a long time ago in a galaxy far away, Oracle ghosted the Java EE community. They basically just stopped responding to email, just said, we don't care, and they just did nothing, right? And so as a result, the entire community process around which Java EE centered came to a screeching halt. And this got so bad, and there was such an so uproarious outcry from the community that eventually the community was able to shame Oracle back to the table just long enough for them to donate Java EE, to make it open source so that it was truly open, right? And this took like more than 6 months. I don't remember. The pandemic has dilated time. But nonetheless, the result was that eventually, after lots of hemming and hawing and negotiations and backwards and forwards, they finally open sourced Java EE, but they had a bit of a poison pill. They said any changes to Java EE needed to be done in a new package, in a new namespace, right? So you couldn't call any changes to the code base Java EE, and you couldn't use the old javax package. So this is bad, right? Somehow the lawyers managed to push through this stipulation, and the result of which is every piece of code ever written against Java EE breaks, right? Not great, not ideal, and there's nothing we could really do. But from a technical perspective, the good folks over at the Eclipse Foundation did a fantastic job of making the migration as seamless and painless as possible. They released a version after that of Jakarta EE with the exact same code as Java EE, literally the same package, same code, same everything, no changes whatsoever. The only difference was it was now licensed as an open source project. They recreated the documentation and the specifications and the Java docs and all that, because for some reason Oracle didn't see fit to donate all that. And that was the new version of Jakarta EE. Then they released yet another version of Jakarta EE in very short succession that was basically the exact same thing, except they moved everything to a new package. So now you've got basically 3 versions of Java EE in a row that were all exactly the same, except for the last one change the package, right? And this meant that there's lots of runway for people to sort of make the jump or to make the migration to the new Jakarta EE stuff without any backwards incompatibilities beyond a quick find and replace. So it's not that big a deal, at least for you, my dear friends. But believe me, it was a huge deal for all of us framework and library implementators that had to update the code and make that work in the new world. And a big part of Spring Boot 3 was managing that process. It was taking all these libraries, ecosystem implementations, drivers, projects, etc., and then commenting them out until their builds matched the new Jakarta EE namespaces, right? And that took a long time in of itself. So I think that's quite nice. Okay, so we have our HTTP server request. We can do things with it. But what I really want to do is I want to return a consistent error that represents what's happening. And there's a lot of different ways I could do this, but one great way to do it is to use the problem details RFC 7807, which is a consistent way to represent errors in HTTP APIs from 2016, right? So going back a while already. And this is supported in Spring Boot 3.0. So we have a, blink and you'll miss it, property here, problem details enabled equals true. Then you can create a problem details representation. So problem detail dot for status, HTTP status code value of, let's say, whatever, 505 or 404, okay? I want to then enrich the data. So I'll say, here's some detail, IAE.get message. And I'll say return PD. And we'll say problem detail. Very good. Okay, so I have my generic controller here, my generic error handler. Let's go ahead and see what happens. I'll go ahead and restart the build and go to the console here. Okay, good. Okay. Perl, Josh, capital J, that works, right? Minus V. What about a lowercase j? Okay, got a 404 error, and you got this nice consistent representation of the error on the console there. So now we can easily, use that same, any API that implements that particular spec can now consistently kind of communicate errors across your API portfolio. Very simple, very small. It's just nice. Okay, returning to our code here. Again, how can I make this code that much more production worthy? I want it to be observable. And to that end, we have the Spring Boot actuator on the class path. The actuator are a set of managed HTTP endpoints that surface information about our application, the health, the metrics, the environment variables, configuration properties, all this kind of cool stuff. But of course, because we are production worthy, Spring is locked down by default. So for our demo, for our purposes, here and now, and only for here and now, I'm going to open up everything so we can see everything. But you want to take considerably more care when you go to production than just to make everything flat out open. Okay, so web exposure include equals everything. We want the probes to be enabled for Kubernetes. We want all the details to be visible. We'll go ahead and restart. And then we go here and we can see actuator / metrics. You've got health. You've got all sorts of cool stuff. But for our purposes, what I care about are the metrics. You see, the metrics are provided by a project called Micrometer, which is a vendor-neutral application metrics facade that ships metrics to any number of different time series databases, things like Prometheus in the Kubernetes ecosystem and VMware's own Wavefront and Netflix Atlas and Datadog and all sorts of other different time series databases. Or, if nothing else, you can see them stored here in memory and captured here in memory. So there's a lot of interesting metrics that get provided for you out of the box just by using the technology. That said, you can capture your own metrics. There's another side to observability beyond metrics, though. There is distributed tracing. And so historically, you've had Micrometer, which does metrics. And then on top of that, depending on that, you have Spring Framework. And then on top of Spring Framework, you have Spring Boot. And then on top of Spring Boot, you have Spring Cloud. And then on top of Spring Cloud, you have Spring Cloud Sleuth, which does distributed tracing. You see the problem here, friends? Spring Cloud Sleuth cannot, Micrometer cannot depend on Spring Cloud Sleuth. Because it would create a circular dependency. Spring Cloud Sleuth sits on top of everything, whereas Micrometer sits on the bottom of everything. It's a bit asymmetric. What I really want is a consistent metaphor by which I can capture both trace information and metrics. And I want to do so in such a way that Spring Framework and Spring Boot and Spring Cloud all can depend on the same API. So in Spring Boot 3.0, we have actually fixed that situation. So metrics and tracing are now both provided by Micrometer, and Spring Cloud Sleuth goes away. So now we have this new unified abstraction as well in Spring Boot 3. So let's go ahead and integrate that here in our endpoint. And the idea is that we're going to, to do this work, we're going to inject a pointer to an observation registry. Okay, registry. We'll add this to the constructor, and we'll say observation dot create not started, and I'll just say by name, or we are devs this dot registry dot observe new supplier, and here we're going to return again a collection of customers. I'm creating a context in which we're doing measurement and in which we are capturing trace information or propagating trace information. So suppose that instead of just talking to my local in-memory database, suppose that I had actually started a network request from one node to another. I called another HTTP endpoint. In that case, this supplier would begin a trace, and that trace information would be propagated in band to the other node, and then that would be published to something like OpenZipkin. So very good. Let's go ahead and restart this. This will give us both trace information if we have the appropriate adapter library on the class path, and it'll give us our metrics. So let's go to localhost customers. Josh, okay, refresh. Go back here, okay, and you can see we have WeAreDevs down there at the bottom, and we have some information about that. I made the call 10 different times. We have total count, etc. And again, like I said, that would also do the right thing when it comes to distributed tracing. Very good. So now I've got an application that is observable. We've got error handling in the same place where we've made the jump to Jakarta EE and Java 17. I think it's now time to think about moving this application to production. Obviously, we need to build a Docker container, an OCI image, and there's a lot of different ways to do this. All of them not great, right? If you want to, all of them save for one, that is. If you want to get a container, the last thing you should do, friends, is write a Docker file. Friends don't let friends write Docker files. That's a surefire recipe for, first of all, work, which I'm slightly allergic to, and also failure. Failure's not good, friends. Don't write your own Docker files. There's just too many things to get right and too little time in which to do it. Instead, leverage the collective wisdom of the community. Use build packs, right? Build packs are technology from the Cloud Native Computing Foundation that make it easy for you to take an application artifact, be it a .jar, a WAR, or .NET EXE, or Ruby on Rails app, or a Python app, or Node.js app, or whatever, and turn it into an OCI image. So it's very, very interesting, but not particularly new. So I won't linger on this point, but suffice it to say that Spring Boot has support out of the box for using that. So I think it's build boot image or something like that, right? You can look at great old tasks, and usually it's in the top there. So let's see here, friends. Boot build image. There you go. That builds an OCI container for you. Good. So we've got part of the problem already solved. The next thing I care about is building an application that is as efficient as possible. Now, that is worth a quick digression. It's worth pointing out that Java is actually a very efficient language, right? There's a study that was done in 2018 where they compared the efficiency of languages in terms of electricity and energy and time and so on. And in that study, they found that Java comes out pretty well. C is a baseline here, obviously, and Rust and C++ and Ada all score favorably. But those are all, strictly speaking, pretty notoriously systems programming languages. Java is a high-level language by comparison, and it still does really well, especially when you consider that its contemporaries, things like Python, are 35 times less efficient, right? And don't get me wrong, I love Python, but that's a pretty crazy number, right? So Java is already pretty interesting. And there are two things that make it so compelling and so persuasive from an efficiency and a performance perspective. The first thing, of course, is the Java garbage collector. Now, of course, I'm not talking about Jesselyn here. She's an engineer, but she's also from the island of Java, Indonesia. She is the original Java garbage collector. And this tweet makes me so happy, because what it means is there is an intersection of people who both appreciate geography and Java garbage collection, right? Lots of people, 20,000 people. This is why the world is not completely bankrupt of hope and joy, friends. It's because a tweet like that can survive. So that's one thing that makes Java amazing, is the garbage collector. The other thing that makes it amazing is the just-in-time compiler. And the just-in-time compiler does its work by adaptively taking code and turning it into native operating system and architecture-specific binary. Now, that said, if it's such a good idea, why don't we just proactively turn all of our code into native code? And the reason is because in order to do that compilation, the just-in-time compiler has to have certain guarantees that it can't make by default, certain guarantees about the code. You see, what it does is it goes through the code, and it needs to make sure that there are no types that will be introduced beyond what are already present at compilation. So imagine you have a Java program. Imagine you can go through the Java program and find all classes that are being used, and all classes that those classes are using, and all classes that are being used transitively, starting from public static void main and then working your way out. If you could find all the classes that are being used deterministically, you could keep those and then discard everything else. The result would be that you only have the types on the class path that your program actually uses, and you would only have the types in the JRE that your program actually uses. This would be a very small program indeed, right? Most programs don't use anywhere close to the sum of all the types on a given class path. Quite the contrary, right? Well, you could do this, but remember, Java is a very dynamic language. I just listed a bunch of systems programming languages with which it has similar performance characteristics in terms of energy and so on, but it's actually a very dynamic language, and it has a lot more in common with the likes of Lua and Ruby and Python and JavaScript and Lisp and whatever than it does the likes of C or C++ or Rust. It is a dynamic language with a runtime. You can actually take a Java lang string, compile that string in, write it out to a Java source code file, foo.java. You could then take that foo.java, compile it into bytecode, write it into a class file, load the class file into the class loader, reflectively create an instance of it at runtime using reflection in class.forName, create an instance of that object, call methods on the object. If the object is an interface, you could create a proxy out of it. If it implements serializable, you could serialize it over a network socket, and you could do all of this at runtime after the code has been compiled and deployed, right? You could do all that at runtime, and you could do it all in terms of Java lang object, never having a concrete type on which to depend. So that's kind of like eval in a lot of other languages, right? It's a phenomenal piece of code, this Java, and I think it's going to go places. You just watch. That is one of the reasons why there is no deterministic mechanism by which we can account for all dynamic types, right? Things that you could do at runtime. It's not possible. So GraalVM is a ahead of time compiler that does this. It tries to do the static analysis, but it can't see all these use cases. It can't deterministically guarantee that it can see at compile time every type that will be there at runtime. So you have to make accommodations. You have to write configuration files for all these dynamic use cases. And as long as every library in the class path and all of your code has configuration file, this program can be converted into a native image. Spring Boot 3 ships an AOT engine. This engine looks at your bean graph, the application context and all the beans within, and at compile time, it furnishes this configuration by analyzing all the beans that your code has, and then writing it out. And for the most part, this should just work, TM, right? Like it's just going to be one of those things that works out of the box. So that said, it won't always work, right? It can't always work because as long as you have other libraries on the class path, there might be issues. So we're gonna kick off a build here, and you'll see it's gonna kick up a build process at compile time. You can see it just started the Spring Boot app, right? That's not the unit test. That's actually it running the Spring Boot application, not starting the beans, but at least understanding the ontology of the beans, the relationships of the beans, right? And it's calculating all the configuration that needs to be fed into the GraalVM compiler. This process actually takes a fair amount of time. It's very inefficient, as you can imagine. And I can finally now understand the legendary XKCD cartoon /303, where they talk about the #1 programmer excuse for legitimately slacking off. my code is compiling. I never got this joke. It never made sense to me as a Java developer why this was funny, because I don't have nearly enough time to do anything useful in a normal Java compile. But with GraalVM, I think we're there. I think we actually do have enough time to get distracted. And that's, I think, the worst, most treacherous part of this is the compilation for GraalVM takes long enough that you get distracted. You get kicked out of the flow. You get kicked out of the zone. But it doesn't take long enough that you can do anything useful. It's not like you actually have enough time to go swashbuckling with your friends on chairs. It's not like you have enough time to go take a little walk or finish that newspaper article clipping you were reading, or make a cup of coffee or whatever. You can't do any of that. You're just forced to sit there glass-eyed and bored waiting for it to finish. And at some point I started to realize that I start to hear elevator music. So I thought, wouldn't it be great if we could actually hear elevator music? Because it'd be nice if everybody else could share in my my delirium. So I went to the Oracle GraalVM project, the official one, and I said, please play elevator music during native image compilation. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. To which I got some great responses, including this gentleman from Red Hat who says, maybe you could play this music, and that music is the GoldenEye soundtrack, the movie from the 90s, and it does sound like a really good elevator music. And then the best response, when one person said, maybe you could play a bell, like a beep, when the compilation is done, so it's done, like a toaster. And then this gentleman, a guy named Fabio Niepaus, and forgive me, Fabio, if I'm butchering your name. I didn't mean to. I think I'm trying to pronounce it as best as I can, but I'm not so good with the name. So he wrote a very thoughtful response. He says, thank you for your feature request, Josh. The problem with playing music during compilation, during the compilation process, is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Anyway, I have prototyped a Josh Long mode, -- Josh Long mode, but for some reason, he says, I have the feeling my PR will be rejected, probably because of the copyrighted music. And then on a more serious note, he continues, yes, we could add a ring bell when done option that prints the bell code after the compilation process. So here's what that Josh Long mode might have looked like, and what could have been my Josh Long mode prototype for the GraalVM native image. Music brought to you by Josh Long, and then yours truly here in an ASCII art. I think that could have been cool, friends. Anyway, the build has more than likely finished. Right? Yeah, there it is. It took about 1 minute and 10 seconds on my machine. Bear in mind, that's a slightly bit longer because I'm streaming. I'm transmitting my computer image to you live, right? And because of that, there's a slight tax, ever so slight, on my CPU. So this might be just that much faster were I to run it without you watching, right? Sort of a Schrodinger's build, huh? So go to the build directory and go to the native and go to the native compile. And you'll see it says service. I'll go ahead and click that. Address is already in use. Am I already running the application here? I am. Pardon me. So let's try that again. There we go. That took 99 thousandths of a second, right? 99 milliseconds, less than a tenth of a second to start up. I got the data. That's fine. I mean, starting up quick is a nice party trick. It's not all that important unless you're doing serverless, in which case, you're welcome. Now you can do serverless. And in fact, we have a module called Spring Cloud Function intended exactly for that, which is to build serverless functions. So that's great. But what I really care about far more than startup time is runtime footprint. And to that end, I think you'll agree that this is a big deal. So if I go up here, I can capture the PID, the process identifier from my application, and I can say PS RSS -O. Whoops, it's the other way around, isn't it? Okay, -O. There you go. So you can see it's taking about 100 megabytes of RAM. Okay, that's a good number, right? That's a very good number. That's probably, I'm just guessing. You can correct me if I'm wrong, but I'll bet most of your Java applications take about 756 megs of RAM, at least just for the JVM, and maybe another 256 for your application proper, making netting you about a grand total of about a gigabyte to have enough buffer in production to be able to run successfully. And that's probably just at a minimum, right? I know a lot of shops run it with more RAM than that. So to be able to run this application at 100 megs, that could represent as much as like a 10-fold decrease in cost, in resource usage. That's a good deal, right? So, okay, we've got our service. Let's build a client, okay? And here, I'm going to build a thing that consumes that API. And there's a few different ways we might do that. We can use Spring Cloud Gateway. We can use Spring for GraphQL, and we can use the reactive web support. We'll enter and build that UAO, okay, UAO client.zip. And I'm going to open this up. Now, the goal here is to take that data and make it available to the consumer in some different way. So there's a lot of different ways we could do this. I can go here. I can say client application. The first way I might do this is just to create a simple API gateway. So route locator using Spring Cloud Gateway, right? So route locator builder, RLB. And I can just create a little predicate, a little route predicate that matches incoming requests intended for this host and port, and this will be 99.99. I'll say rs.path, that's the matcher on the incoming request. When that path is matched, I want to forward the request. I want to proxy it, basically, to localhost 8080, and I want to send it to the customer's endpoint. So you go to 99.99/proxy, and you should get the data from localhost 8080 customers. But obviously, the path on the incoming request is proxy, and I want to send it to customers, but what will actually happen is I'll end up sending it to customers proxy. I need to swap out or switch out that path, and I can do that using a filter here. So here, I'm going to use a filter to set the path of the incoming request before I forward it onwards. And the filters are really what adds most of the power to Spring Cloud Gateway. I can do retries and rate limiting, and I can do, maybe I want to add a response header, like this, add response header, HTTP headers dot allow origin, all sorts of interesting things you can do there. For our purposes, I think that's a good start. So let's go ahead and start that up and see what we get. Go to localhost 99.99/proxy. Okay, and there's the data. It's worked. And of course, if we go to the command line, curl -v, you can see that we have the access control allow origin header on this proxied endpoint that's transmitting data from downstream. That's one way to do it, certainly. Another might be to just talk to the API directly, to build a client. And you could, of course, get a hold of a REST template or a reactive web client and do the work manually. But I prefer to let the machine do this kind of stuff for me. One way to do that is to create a declarative client based on an interface. So I can say customer client, and this is a feature that might look familiar. You've probably used Spring Cloud OpenFane or Spring Cloud Square retrofit or Spring RetroSocket, right? These are libraries that, given an interface, will create a client that talks to HTTP or RSocket services. And there's discrepancies in the programming model. They're inconsistent. Some are using reactive, some are not. Some are using HTTP, and some are using RSocket. In Spring Framework 6, we've implemented a new mechanism that is now the core abstraction, and that is this, right? So I can say I want to provide a client, and I want to return all the data from the downstream service, right? I'm going to use that record again. So we'll say return all the data. So there we go. And we'll do another endpoint here, by name, string name. So I'm going to define an interface. In order to tell Spring about how to map these methods, I'm going to use this new annotation called getExchange, which is sort of like a client-side peer to Git mapping. Okay, so there's my basic, client. I'll use the path variable there as well to tell it that that URL template is important. Now I want to create a bean that implements that interface. So customer client, and I'm going to use the reactive web client here. I'll say return web client adapter dot for client, and I'll use the builder, and I'll create a base URL, HTTP localhost 8080 dot build. All right, and then I'm going to let's see, var wca is that. Then I'll create an HTTP service proxy factory builder with a WCA in there, and I'll build it, and I'll create a client for that type, like that. Okay, so this is a very simple way to create a customer client, and then I'm going to inject it like that, and we'll use it when the application starts up to make a call to the downstream service. Okay, so ready, and I'll inject the customer client. Voila. Okay, so return new application listener, and we'll say, give me all the results, and I'll just print them out as they arrive. Okay. Fantastic. Let's go ahead and restart that and see what we get. We get nothing. No. We did something wrong here. There we are. That should do. Okay, so the application started up and it made a call to the downstream service. I didn't have to write the networking code. I didn't have to craft the HTTP request or whatever. I let the machine just automatically build me a client based on the interface. How convenient, right? So now I've got a reactive client to talk to my service. I can also build a non-reactive one, but I quite like reactive code for networking calls because it makes it easy to compose and so on. So the next thing I might want to do is to actually take that data and expose a sort of federated view of the world. And that's a natural thing to do with GraphQL. So I'm going to go to the source main resources directory, and I'll create a folder here called GraphQL. And in there, I'll create a schema file, schema.graphqls. And in GraphQL, you have three main verbs: queries, mutations, and subscriptions. Queries read data, subscriptions read data that is ongoing, like sensor feeds or stock takers, and mutations make changes to data. When I say make changes, I mean delete, update, create. Okay, so I'm going to create a type that exposes a read operation called customers, and it's going to return an array. That's what the bracket syntax is, of type customer, like so. Okay, and I'm going to define that as having an ID and a name. All right, very good. And then what about the customers by name? Okay, so customers by name, name, string, like that. So I've got now two different customer fields, and I've got two different read operations. I want to implement those in my Spring application. So I'll quickly create a GraphQL controller here using Spring for GraphQL. I'll say add controller. We saw this earlier, remember? Customer GraphQL controller. And I'm going to inject the customer client that we just painstakingly built. Okay, at controller. And we're going to create a simple query mapping endpoint, returning a publisher of all the customers, so customers. And we'll say return this.cc.all. And we'll create another endpoint here, flux of customers by name at argument string name. And we'll say return this.cc.by name, passing in the argument there. And then obviously I want to test this out. So I'll go back to my property file and I'll enable the console called graphical. Okay, before we restart the application. Here we are. Go to the browser, localhost 8080 /9090 graphical. Okay, and there's our shell, kind of a client that you can use to interact with it. So I want to create a query. Notice that I get type completion and that kind of stuff. So I can ask for all the customers that have the name Josh. I can ask for the ID or the name data. I get it back if I want. I can ask for customers, get back just the ID data, for example. I get that as well. And the nice thing about GraphQL is I can easily interstitch other different types as well, and I can easily add to the graph so that from the client's perspective, it looks like all my data is in one service, one fell swoop. I can actually interpolate. I can mix this stuff together. But obviously, behind the scenes, it could be two disparate network calls to two different microservices. So it's the best of both worlds. My bandwidth constrained, battery starved, resource starved clients, my Android devices, my iOS devices, etc. They get all the data they want in one fell swoop. But behind the scenes, I can keep my services separate. This is the power of GraphQL. Now, of course, friends, everything I just showed you, the GraphQL, the declarative interface clients, and of course the Spring Cloud Gateway code, all that works in a native image as well. So I can say Gradle W native compile, and I'll just let that run in the background. Oops, what did I do? Oh, I forgot to add did I forget to add the GraalVM support? I did. Easy fix though. So we'll go back here, make sure to add the GraalVM native support. Okay. Copy and paste all that. Refresh, reload. Good. Native compile. Here we go. So that'll take its time. And in the meantime, friends, I'm happy to answer questions. I want to first of all just tell you, thank you so much for your time today. I hope you got something out of it. I really wish we had enough time to really get into the weeds and see some stuff. We barely saw anything. It's a bummer. Maybe next time. Yeah, thank you. I'll let this run in the background. This will take about another minute. Are there any questions?
Josh, hello again. Thank you so much for the talk. Yeah, sorry that there is not much more time, as we only have one hour slots. But next time you could like elaborate a bit more.
Yay!
Like in an additional talk. So yeah, let's do a quick Q&A. I would say we already talked about like I call it developer journeys of some of our speakers today. So maybe you also want to share some insights on how you began with coding and how you got where you are now.
Oh, yeah, I don't know. Boy, I learned programming in the 90s, as I think a lot of people in then and now. I think I was looking for the fast feedback of a change on my screen, right? So many of the programmers that I know, they got into it because they wanted to build video games. I didn't want to build video games, but I did want to use software to manipulate graphics, right? So that was one thing led to another. But I was in it for a reason as opposed to for a theory. So I wasn't a very I didn't understand the motivation behind like object-oriented programming. It wasn't until I had an opportunity to spend a summer in the south of France cleaning the gutters and mowing the garden and whatever for a couple that my dad met. Long story, but anyway, I had there's a book called Thinking in Java by Bruce Eckel, and this book was phenomenal. And I read it page cover to cover, wrote down all the examples, tried them out, and it didn't just explain why and how you can write Java code. It explained how to write object-oriented code, and it motivated object orientation in a way that I just really hadn't appreciated before. And the rest is history, right? From there, it was just a love affair. I just loved the Java ecosystem, and finally, I went from one startup to another. And in startups, you have to wear a lot of hats, and you don't get to be a specialist. You just sort of have to get the thing out. So a lot of these people I know were slogging through, whatever technology the distinguished competition was offering, and they were just disgustingly inefficient at building services. And so here comes Spring. And it made me feel like I wasn't crazy, right? I remember just watching going, this can't be how we build software, right? Before Spring came along, I thought, I'll just leave. I'll just go become a .NET developer. This is insane. I don't understand how we're supposed to make this work. And what I'm talking about is, the J2EE. It's much better now. Java EE is a far sight nicer, obviously. But back then, for J2EE and EJB 1 and 2, again, 3.0 and Java EE5 are a whole different story. I'm not talking about that. I'm talking about the very early days. I remember, there were books, whole books. When was the last time you had many different publishers publish books about how bad something was, right? Technology. Imagine an O'Reilly book that only existed to tear something to shreds, right? That happened with EJBs 1 and 2. That's how bad it was, right? Multiple publishers bankrolled print runs of books, and authors spent 6 months writing about how bad EJB 1 and 2 were. And that it helped me to kind of understand I wasn't the only one who didn't understand how to take this technology and get to production with it. It was just too hard. And so here comes Spring, and it made me feel like, oh, there is a way to use Java and be productive at this scale when building enterprise apps. And so I just really, as a person trying to get into production very quickly, because I was working at startups, I just loved Spring. It made me feel like I wasn't, I didn't lose my mind, and it was possible to be productive. So I was using it in earnest, in anger, at a lot of different companies, and I wrote books about it, and I was speaking at conferences, and eventually in 2010, I was also a contributor. I am still a contributor of lots of bugs. I have contributed so many terrible lines of code to the Spring code bases over the last, decade and a half. Eventually in 2010, despite all my terrible patches and contributions, the Spring team said, hey, we've got this new job for a developer advocate, and you're already doing this kind of work. You would be our first developer advocate. Would you like to come in out of the rain and let us pay you to do what you are already doing on your own time and dime. And I said, nah, that's not for me. I couldn't do that. That's not me. And then I walked away from the computer. I closed the window with the engineer who was offering me the job. And then I got like 5 minutes away. I was like, wait, no, yes, I want to work with you. Yeah, yes, I'll take it. I'll figure it out, And the rest is, well, they haven't fired me yet. It's been a good run.
Your fingers crossed.
Fingers crossed every day, especially in this economy,
I root for you, Josh. I root for
Cheers,
you.
buddy. Thank you. Me too.
All right. Thank you for this awesome story, Josh. We have some more bit technical questions.
Cheers.
First would be, hi, Josh. Great presentation.
Oh, thank you.
What is current adoption rate for GraalVM?
It's a niche, I think. I don't know that it's going to ever become like 100%, right? But remember, first of all, I don't have concrete numbers, but I can tell you kind of a perspective here. Recently, at Java 1 last year in October, Oracle announced that, because remember, GraalVM it originated at Oracle Labs, which is part of Oracle, and the lead contributors to Java proper are also Oracle, right? It's not OpenJDK is open. It's not technically an Oracle effort, but there's no denying that a good many engineers that work on OpenJDK happen to be salaried at Oracle. So it felt very weird for the longest time that GraalVM was being developed at Oracle, and it's an OpenJDK distribution plus, and OpenJDK, a lot of that was being developed at Oracle, and yet these things didn't align. In fact, the release cadences were different and all that. So at Java 1, they announced that they were going to they were going to donate GraalVM Community Edition to OpenJDK. And then very shortly thereafter, all these sort of documents around Project Layden, which seeks to introduce condensers, right? The idea that you have a continuum of optimizations that you can make to your Java source code to produce a more efficient binary by sliding when things are evaluated, either at compile time or at runtime, along the spectrum. The idea was that you would have lots of different opt-in condensers that you could use to, as a gradient, like I say, as a gradient to, depending on what your use cases are and your preferences and your tolerances are, to get more performance out of your application. You could make more concessions and in exchange get more performance and more efficiencies. So they announced this Project Layden years ago, but right after that OpenJDK announcement, that donation of GraalVM, suddenly Project Layden started talking about GraalVM, right? Like that was going to be a big part of the future, which everybody kind of thought had to be at some point, right? Like you can't do Project Layden without GraalVM, but for some reason they never talked about GraalVM. It was just sort of like some nondescript generic AOT library that somewhere, some way will arrive. It's like, what are you talking about? It has to be GraalVM, right? So finally, that seems to be a little bit more clear. So all that to say, it looks like GraalVM is going to be, if not in the OpenJDK as part of like the main programming model, then it'll at least be, developed in tandem with and be a major part of the lineup and the arrangement and the release cadence of OpenJDK. So even if it's a niche utility in OpenJDK, like even a small component in OpenJDK is by definition a big component in the absolute sort of vacuum of the entirety of the ecosystem. So I think it'll be here for a long time, and it'll be very important, right? It's just an amazing thing that they've done here, and it's obviously still early days yet, right? Remember, GraalVM they didn't even have like a stable release until recently, So yeah.
Should we share your screen again for the result? Is it ready yet, or
what is ready? Yeah, the client.
Yeah.
Yeah, my screen.
If you want to show it, yeah.
Is it showing? When did I turn off my screen? Let me see. Yeah, it's my screen is sharing. Is it?
Yes. All works.
So here's the client, right? Control C. Do it again.
Awesome. All right, maybe we can jump to the next question.
Sure.
Meanwhile, where do you see Spring Web Flux when Project Loom comes around?
I think, so Project Loom makes Spring Web Flux all the better, right? So you should try it out, people. You can actually try it out right now. Just take Project Loom. Remember, Project Loom at its core is a virtual thread pool. So you can actually create a bean of, Tomcat embedded Tomcat customizer, and then you can override the thread pool. Just plug in a Loom thread pool, right? Using say executors.virtual thread pool. Make sure you enable the preview feature. And if you debug it, if you put it into the profiler, you'll see that your Java program does indeed use far fewer threads, right? By default, Tomcat gets without a virtual thread pool, you have like 200 threads, I think, in Tomcat. It goes down to 4, right? Which is phenomenal, right? That's amazing. So Loom is going to be a phenomenal way to build that kind of stuff. But that said, reactive programming isn't just about reuse of threads. It's not about making your thread pool smaller, right? Interesting though that is. It's a way of doing structured concurrency. And so as long as building concurrent code is unsafe with regular Java lang threads, I'm going to recommend reactive programming. Just like reactive programming is one way to do it. There's other ways to do structured concurrency, right? Actors is another, right? It's just about having a safe way to define multi-threaded code. Reactive code is also great for doing service orchestration and composition. It's great for basically any kind of pipelining. It's just a good way to write code. So I think in that respect, Loom will just make everything better, even more value. And it means that you can take existing apps that don't have, efficiencies around thread reuse and so on, and hopefully make them that much more efficient for free just by changing the thread pool. That said, it's not a panacea, right? It's not gonna give you everything. You should try it out, really, because remember, it only works for things for which there is a non-blocking or NIO-based alternative, right? So, like file system IO, there's no NIO module there, right? There's nothing you can do there, so that doesn't get that much faster. You're not going to see huge gains in that. Network IO, sockets, and all that stuff, yeah, you'll see something big there, right? Obviously, so it really kind of depends on the use case. If you're talking about just network IO, yeah, you'll see hopefully an improvement there. Yeah, it's really amazing, and there are some things out there. So many interesting things out there. The other thing I'm really excited about, besides Project Loom, is checkpoint and restore, crack, right? This thing. It is possible now to build a application, exercise it, put it through the integration tests and so on, and then checkpoint, capture a dump basically of its state after it's been loaded and warmed up, and then use that to boot the application directly to that state in production. And this is insanely fast, right? It is faster than GraalVM by orders of magnitude. If this took 100 milliseconds, your checkpoint and restore app might take 1 or 2 milliseconds. It is so fast. Already GraalVM is faster than a light bulb, but checkpoint and restore is I don't even know. There's no way to measure it. You'd have to write custom code to even capture the delta and the time it takes. It's so fast. So these kinds of things, Crack and Project Loom, they offer some incredible benefits. And I hope people will experiment with it. You can already start using this stuff now, right? The Tomcat embedded customizer is actually where you would start with both Crack and with Project Loom. Mark Paluk, Loom, virtual threads, reactive, whatever. He wrote a great blog a few months ago talking about some of the potential extension points for virtual threads in the Spring ecosystem. Remember, Loom is not yet GA, so we can't release anything yet because it's not officially a thing, right? It's not even there yet. But we are looking at opportunities to embrace it. Spring itself has already done a lot of work over the years just because of our work with reactive programming to remove any scenarios that might cause deadlocking in a virtual thread context. One of the things that is a common lament is that if you have synchronized blocks around input streams and output streams, then that's not going to be very good in a virtual thread universe. You need to find ways to do that locking without having the input and output inside of that. Otherwise, it ends up deadlocking. And so we actually do very good on that already because of all the work we did in reactive. So Spring's in a great place. All that stuff has already been discovered. And so we have a very good, citizen in the virtual thread scenario. But yeah, here we go. Tomcat protocol, handler customizer, return a protocol handler.setExecutor, executor's new virtual thread per task executor. And then same thing for, the async task executor that you might use for like message dispatch and Spring integration. You just plug in one of these new virtual thread per task executor. It's not hard to try it out right now, like I said.
All right. Thank you so much, Josh. Another question: GraphQL or gRPC? Question.
Look, I quite like RSocket, but I gather that's not where a lot of the ecosystem is right now. So I don't really know that. If I had to say, I'd say use RSocket and use GraphQL, because remember GraphQL runs on HTTP, but it can also run on WebSockets. It can run on RSocket. It's protocol agnostic. It's only incidental that it uses HTTP in this case, right? I just used the default implementation. We have support for running GraphQL on top of RSocket. Now that's best, right? That's like binary protocol, blazing fast, super efficient, built by people at Netflix and Facebook for their service stack. And also, unlike gRPC, it doesn't require code generation and that kind of stuff. So yeah, I would just use those two. But gRPC is fine. Obviously, people use it. It works well. There's a number of different, very convenient implementations in the Spring ecosystem. And certainly, if that's where your center of gravity is in your project and your organization, then yeah, use that. Why not?
Right. Thank you, Josh. One more question. Is GraalVM really successful in production, provided it still doesn't support things like Mockito, etc.?
Well, so there are some, caveat emptor, right? Like nothing is 100% yet. So GraalVM, one of the big things that you're going to find is, it doesn't support Java agents, right? And so if your observability story relies upon having a Java agent present in the class path, well, you're going to be sorely disappointed, right? And so this is why I always talk about the new actuator stuff, the new observability story, because it's more important than ever to have the in-code, in-app observability instrumentation, right, in your application proper, as opposed to a Java agent underneath your application. You want to be able to capture all that information, and Spring makes it trivial to do that. It's just not a Java agent, right? You're doing it in the programming model itself. Mockito is another thing. There's work being done on the Mockito side and on the GraalVM side, right? The GraalVM team is super responsive to like, hey, this use case isn't well served, or can we make this kind of thing work here? But yeah, it's not a free lunch. There are some concessions you're going to have to make to get this result. Actually, in the Spring example I showed you, remember what I said. When you create a GraalVM native image app, we look at the state of the bean factory at compile time, and then that's what's configured for runtime, which means that you can't change the bean graph in a native image. So there are some features in Spring that let you create a dynamic bean graph. You can have some beans that exist at runtime that don't exist. They might exist on this run of the application, but they don't exist on that run. One thing that does that is profiles, right? You can have labels that selectively add objects to the bean graph based on the presence of an environment variable or a command line switch or whatever. Well, that doesn't work particularly well. You can do it, but you got to make sure that you compile with that profile active. So I think it's just better and easier to like not have profiles in that case, right? There's some corner cases. I think most people will be just fine, but I think it's I don't know. I don't know what the answer is. It's not 100% free. Nothing is, but I think it's worth production if you can navigate the potential pitfalls.
Right. Thanks for enlightening us, Josh. This is also not the first talk you had at the WeAreDevelopers event. You spoke at our World Congress last year, 2022. Yeah. Maybe you want to share your experience from the Congress?
Yeah, that was good. I got they gave me a kind of a tiny room, and what happened? That's in Berlin, right? So that was last summer, I suppose.
Yeah.
That was a lot of fun. I remember giving a presentation, and it was really nice, coming out of the pandemic to be there and to feel that energy in the room, and it was huge. That We Are Developers show is massive. I'm ashamed I didn't really know about it before. But you're definitely on my radar now. That's a good show, good community. Good to see some amazing people. Actually, one of the people I saw there was my buddy Vincent Myers, who is at Gradle, and he actually is here in Atlanta, Georgia. Funny enough, so I was actually talking to him, and I bumped into him at We Are Developers in Berlin last year. Yeah, it was a good show.
Small world.
Very small world, thankfully.
Yeah. All right. Joss, thank you so much for the awesome talk, also for the Q&A and your kind words. I wish you a nice rest of the day and hope to see you soon. Bye.
Likewise. Bye-bye. Cheers.
Bye. Cheers. All right. And as this first episode of the season 5 also comes slowly to an end, just few things. First of all, thanks to our amazing partners who help us to make shows like this happen. To check them out, scroll down on the live page where you find all of their logos, which are clickable images, and just click through them and look at what they're offering. Also, quick reminder, while you're on the live page, we want to give you, together with our partner Deloitte, a MetaQuest 2 VR headset, and all you have to do for it is to click the button to join the referral, and you're good to go for that. Also, if you want to make same experiences like some of our speakers today at the World Congress, go to worldcongress.dev for further information and to claim your tickets. And now I want to thank you, the audience, for joining us today and engaging so much in the chat, and hope to see you soon, maybe on the Vue.js Day on February the 1st in 2 weeks. Right then, have a nice rest of the day. Stay tuned.
One of the best events, or if not the best event